Good morning to all the delegates, dignitaries, professors, and participants present today. On behalf of MIT University Uttar Pradesh, Department of Computer Science and Engineering, MIT School of Engineering and Technology, I, Dr. Shilpi Sharma, feel privileged to extend my warm welcome to one and all for the keynote address for Confluence 2022 12th International Conference on Cloud Computing, Data Science, and Engineering. Even though we would like to invite you, ma'am, Dr. Lizzie Kurian-John, to our campus and have a keynote session in person, but current world scenario impede us from doing so. Luckily, we are grateful to have the opportunity to keep the keynote session in virtual mode so that our students can reap the seeds from the knowledge gathered in the session. Today, I'm profusely elated to take the opportunity to invite our honorable speaker, Professor Dr. Lizzie Kurian-John from University of Texas at Austin, USA. Ma'am holds the Cullen Trust for Higher Education, endowed professorship in electrical engineering in the Department of Electrical and Computer Engineering at the University of Texas at Austin. She is a fellow of the National Academy of Inventors, a fellow of IEEE, a fellow of ACM. Ma'am received her PhD in computer engineering from the Peninsula State University. She joined the University of Texas, Austin as a faculty in 1996. Her research is in the area of computer architecture, multi-core processors, memory systems, performance evaluation, and benchmarking, workload characterization, and reconfiguring computing. Ma'am, we invite you in this platform to share a few words with us on predicting performance of data centers at scale. We welcome you, ma'am.
Good morning, and it is my pleasure to be here. And thank you, Dr. Sharma, for the welcome. And so I will start talking on my topic, which is predicting performance of data centers. So let me share, I have some slides prepared, and so I will start sharing those. All right, so the topic I have chosen, seeing that the conference is on cloud computing, I chose the topic of predicting performance of data centers at scale. And so I direct a lab called Lab for Computer Architecture at UT Austin. And so let me tell, I'm actually a computer architect. So computer architecture is my main design research area, and microprocessor design is my thing. So when I think about data centers or cloud computing, it is basically all these cloud servers that we design and how should we design them. In order to design them properly, we really need to know what applications are running on them. So as a computer architect, when I look at things, really, 2021 was a very special year for computer microprocessor designers because it was the 50th anniversary of the invention or the design of the first microprocessor. So I actually organized a couple of events to celebrate the 50th anniversary of microprocessor. And you can actually watch a panel that I organized at a conference called the International Symposium on Computer Architecture, where, a lot of famous designers. So this guy, Federico Faggin, is the designer of the first microprocessor. John Hennessy is a founder of a company called MIPS and many other things. He was president of Stanford University. He's still at Stanford. David Patterson and Hennessy together wrote computer architecture books. So these are all founders of companies, CTOs, CEOs, all kinds of people who participated. So that explains what kind of work I do in my research every day. I also organized actually another event because I did a special issue for IEEE microprocessor at 50, and you can watch this video on YouTube also, micro special issue release event, where basically I had the privilege to be with Intel CEO Pat Gelsinger, Federico Faggin, the designer of the first processor, and IEEE Computer Society President Forrest Schultz. Why am I talking all these things to you? Because everything I'm going to be talking today is going to be influenced by my computer architecture background. So these people who are all computer architects, so, that's when we think about cloud and we think about data centers, what the kind of things that go through our minds. But we need to think about the software that's running on the servers. And so I want to use a quote that Chris Rowan, this guy here, he is a founder of a company called MIPS, which made microprocessors, a company called Tensilica. He's also a founder of Babel Labs, who do language translation. He's a VP of engineering at Cisco. So this guy, one of the things that he said at this panel was, a modern application developer who developed these applications that run on the cloud, okay, does not think very much about instruction set architecture. They don't even think about operating system interface or the compiler. They're often working at the level of Python or JavaScript. They are invoking libraries, they are invoking cloud services, and they stitch together these things, and how these things are stitched together is basically architects, processor designers, hardware designers like me. We need to understand how this happens and what actually runs on hardware. Then only we can design good hardware. So a lot of things I do is to understand the workload and what does it do so that we can design matching hardware. So in my effort to understand software, so when it comes to software, basically, software designers and developers, the name of the game is productivity. Humans, the value of humans is very high. Time of humans is extremely important. So we need to have methodologies by which humans are able to produce more. So productivity of software. So software engineering has been driven by productivity concerns for the last, 20, 30 years. So, and also when you look at software trends, you hear two terms quite a bit, microservices and serverless computing. So basically, applications have evolved quite a bit in the last 3 decades. In the 1990s, you had ERP software, enterprise databases, packaged applications. In the 2000s, it became smaller, maybe slightly packaged modules. And then in the 2010s, it became microservices, composable business capabilities, small pieces, microservices. So this applications have changed from monolithic to service-oriented architectures to microservices to serverless computing, which is the kind of the newest thing. So what are microservices and serverless computing? Microservices basically are intended to reduce the complexity of monolithic systems. Means the entire application is one thing. Instead of that, the monolithic systems was the traditional way software used to be organized. Now it is about service-oriented, one service-oriented architectures on which small and autonomous services with a single and clearly defined purpose is created, which is a microservice. So basically, you are vertically decomposing applications into a subset of business-driven independent services. And these microservices are connected with lightweight communication protocols, usually HTTP application programming interfaces or APIs, or remote procedure calls or RPCs. So basically you have a lot of vertically decomposed microservices which are connected through these APIs or RPCs. And then the newest trend is serverless computing. Serverless computing does not mean there is no server. There is a server, but it's basically a platform to efficiently develop and deploy applications to the market without having to manage any servers yourself. So the underlying infrastructure is not managed by you. That's all it means. It doesn't mean there is no server. There are servers. Developers worry about their systems instead of operating their servers. So basically, applications become workflows or distributed logic or externally managed data stores. Cloud provider dynamically allocates the servers, but the application developer doesn't have to worry about the servers. They just worry about the workflow. So the code is executed in event-triggered containers. And different technologies belong to the serverless class. They may be organized as a backend service or function as a service or FAS. And you may hear the words fast computing. So the AAS as a service, and there are lots of things as a service: infrastructure as a service, function as a service, backend as a service. So everything, all these things are as a service, something is offered. So as an example of a backend as a service, Google Firebase, it is a fully managed database that can be used directly from an application. And for examples of FAS, these are functions that are created to maybe manipulate JSON files, get some data and find the max, copy an array. So these may be, these are functions. So these functions are offered as a service. You can use the function on a cloud server. So these are all kind of new paradigms that have emerged into the software field. And I, who is a hardware designer, I'm a computer architect, but I have to understand all these kinds of things in order to design good microprocessors. So that's why I come here with hardware background, but at the same time, this effort to understand how is software organized now. And so when you look at modern applications, whether they be social media, online messaging, web search, video streaming, all these kinds of applications, there are billions of users. They require hundreds or thousands of servers. Amazon, Netflix, LinkedIn, Facebook, they all have adopted this microservice paradigm. Serverless computing is actually enabling fine-grained, short-lived cloud execution. So essentially, the web service development has improved because of these reasons. Scalability has improved. So from the software point of view, there are lots of advantages to having microservices and serverless computing. So when you take a photo, the file is uploaded to some database. A photo resize function is triggered. The resize function is run on a function as a service system, example, Amazon's AWS Lambda, or Microsoft Azure, or IBM Cloud Function, or Google Cloud Function. Somewhere a FAS provided, the function as a service provider, provides that. So you invoke that resize function somewhere, the photo is resized and it is ready to be displayed on the web or on mobile. So when you do something like that, which most people do these days, there is a function as a service being called somewhere. And so when we design hardware servers, we need to understand how these things operate. And that is why it's important to understand this. Now, as a hardware designer, for when I look at these things, it's basically whenever you are doing things like this, what are the kind of overheads over if you had just directly done the thing you wanted to do? There are plenty of overheads. So we just studied function as a service, and we made a few benchmarks. And we need benchmarks to be able to kind of quantify things and then design better hardware. So this y-axis is a log scale. You can see 2 to maybe 15 times overhead. Things are running 2 to 10 or 12 times slower when you have made them into a container or into a function as a service. So it's like there are these services. From the software point of view, they have lots of advantages. It enables quite scalable development, lots of good things, but there is this big overhead. So just like in the picture, you see Santa carrying this present, this is so big. So the overheads associated with providing this nice function as a service or the virtualization, which are all good from the software side, the overheads are very high. Orchestrating the function or orchestrating this microservice, there are plenty of overheads. When you receive a remote procedure call, a microservice should do input processing, IO processing. It should decompress do decompression, deserialization, decryption before it can execute the main functionality. So in addition to the main functionality, quite a lot of other things have to happen. Basically, half or more than half of all what happens on a server is basically this overhead of orchestrating this function. So this particular paper, the blue is the actual work. The yellow is the overhead of orchestration. And you can see that 42 to 67% of different applications is basically the overhead. Performance is lost at every step of your convenience. The microservice, function as a service, they're all very convenient, but a lot of performance is lost at each step of the convenience. Java or JVM, Java Virtual Machine is used. It's very convenient. Code is portable, lots of advantages for virtual machines. Lot of performance is lost. Scripting languages, Python, very popular, very convenient, lots of overhead, performance is lost. Just-in-time compilers, interpreted languages, very convenient, but lot of performance loss. So essentially, everything that looks convenient starts eating up the performance. So a lot of time during the execution is lost because of these conveniences. This was study from a master's thesis from, which showed that the bare metal service, compared to the bare metal service, when you have a Docker or when you have virtualization, things may be running 2,000 or 3,000 times slower. So the overhead of the convenience is very large. And that needs to be understood by hardware designers. And another observation, microservices take longer than monoliths to recover from quality of service. QoS stands for quality of service. And if you have QoS violations, so this picture, the green line is the traditional type of monolithic application. The red one is the microservice. So if you have the tail latency, the worst case latency is observed by the queries, can go, basically the latency can, so this may be the average and the norm, but at times things can be really bad. They are equally bad for both monolith and microservice here, but the monolith recovers very quickly whereas the microservice does not recover that fast. That was an observation from the Cornell University study. It was also observed that there are more quality of service violations if the processor is running slow. So in this case, in this pictures, the yellow shows there are violations in the quality of service. So if the processor frequency is 2.4 gigahertz, there are fewer violations. If it is 1 gigahertz, there are lots of violations. Violations start QPS is queries per second, and even at low queries per second, there are violations if the processor frequency is low. So hardware designers need to understand these kinds of things if they are to design good cloud servers. So one of the things that we have been doing in our research is to create benchmarks to model these kinds of things. And the benchmark can be used when hardware is being designed. So creating a tunable benchmark is one of the things that we have been working on, a portable benchmark with adjustable benchmark. It has some knobs, and you can configure the benchmark in such a way that you can use it for design of hardware or for the servers. And we basically have put some effort into understanding the characteristics of real applications, modeling it, and putting it into a benchmark. So the approach is you profile the workload, you tune the data set and the mix of queries, and then you basically try to create a benchmark that matches the actual applications. Then you can validate or verify that you have a good benchmark using multiple platforms. So data center benchmarking, we take original workloads and then you create simplified performance clones, which are used as a benchmark. And once you have created that type of a benchmark, which has knobs and which are adjustable, I can adjust the value at which the knob is kept. So you can create many useful benchmarks from one benchmark, which has the adjustable. So basically the original workload, you get the important characteristics and then you create a performance clone, which is the benchmark. And we have some research that's going on about making these kinds of proxy workloads. And CPU utilization, the processor's utilization, the DRAM's bandwidth, the network's bandwidth, these are all characteristics that are considered in the creation of the benchmark, because when you make hardware, you have to design the bandwidth correctly, you have to design caches, you have to design translation look-ahead buffers or TLBs. The branch predictors are important. So all the hardware features are tuned based on what is expected in the benchmark. And I don't want to go into details, but we have to really go into details of all kinds of pieces of the hardware and model them. We have to find all kinds of functions that run and classify them and understand them. And once you understand all these features, you put it into the workload or the benchmark. So, in addition to this topic, I also have a few other topics that go on in my research group. We design hardware architectures for machine learning. We basically have processing in memory architecture. So that's one of the new things that's happening quite a bit now. Instead of processing in a CPU, some processing is done in the memory itself. GPUs, like the ones that NVIDIA makes, they are very popular in accelerating machine learning, high performance computing workloads, all kinds of workloads. So we study, in my research group, we study workloads quite a bit. We also accelerate them using hardware accelerators. So, and design in FPGAs or field programmable gate arrays are something that's used to accelerate servers, accelerate remote procedure calls, accelerate machine learning. And I also have some research where we design not commercial FPGAs, but very special FPGAs tailored for machine learning. So I have all of those kinds of research going on in my research group, and cloud related research and designing hardware for emerging or futuristic cloud servers is one of the topics, which is where the benchmarking I happen to talk detail, which one basically is important. Anyway, I want to stop. So if there are any questions, you could ask the questions. So I'm stopping a couple of minutes earlier than so. And so is there a way attendees can ask questions?
Ma'am, we will be getting questions through the chat, not into this, because they are in the virtual session. They are ongoing.
Okay.
So they will be asking through the link. So
Okay.
Thank you, Dr. Lizzie, for enlightening words. It was a pleasure to listen to you give insights about predicting performance of data centers at a scale. We feel privileged to have your supervision backing us. Your talk was particularly insightful. And at the time when the students are considering new ideas to broaden their knowledge for expanding growth in the field of data center, I believe your words have set new levels of expectations that our students aspire for. On behalf of Amity University, Uttar Pradesh, I would like to extend my warm gratitude. Knowing how busy you are, we appreciate the time you took to impart us with your valuable knowledge. We are highly grateful to you, ma'am. Thank you so much.
Thank you so much, Dr. Shilpi Sharma, for the introduction, as well as the thanks, the gratitude that you expressed. It was my pleasure to be here, and to all the students and faculty and others who are attending, thank you for listening. And if you have questions, let us know, but there are a lot of research opportunities in all these areas. So keep learning more, and there is a lot to be done in this world at this time.
Thank you. Thank you. Bye, ma'am.
Thank you. Bye.
We will be starting in next couple of minutes with the keynote address. Do tune, please.
Good morning, all of you. Dr. Christopher Stewart, Associate Professor in Computer Science and Engineering Department from Ohio State University, USA, will be joining soon.
Okay, guys, can you hear me? Yeah.
Yes, sir. I can hear you, sir.
Okay, we can start.
Yes, sir. Just give me 1 minute, sir.
Okay. Can I share my screen?
Yes, sir. You can share your screen, sir. Good afternoon to all of you. Good afternoon to all the dignitaries, professors, and participants present today right now. On behalf of Amity University, Uttar Pradesh, Department of Computer Science and Engineering, Amity School of Engineering and Technology, I, Dr. Prabhishek Singh, feel privileged to extend my warm welcome to one and all for keynote address for CONFLUENCE 2022, 12th International Conference on Cloud Computing, Data Science and Engineering. Even though we would like to invite you, sir, to our campus and have the keynote session in person, but current world scenarios impede us from doing so. Yeah. Luckily, we are grateful to have the opportunity to keep keynote session in a virtual mode so that our students can reap the seeds from the knowledge gathered in this session. Today, I am profusely elated to take the opportunity to invite our honorable speaker, Professor Dr. Vijayant Sagyan Ashivadam. Sir received his PhD in Intelligence Systems from Queen's University, Belfast in 2002. He is currently working as an associate professor with University Technologies, Petronas, Malaysia. His research interest includes linear and non-linear system identification and spatial maps. He serves as executive committee member for the IEEE Signal Processing Society Malaysia chapter. He has worked with consultants on building software solutions, which gives insight from base data, statistical, historical insight, and looking into the modeling and validation with open and free software for small to enterprise solutions. Sir, we invite you on the platform to share a few words with us. Sir, please, over to you, sir.
Okay, before that, can you hear me? Yeah.
Yes, sir.
Okay,
Yes.
right. Fantastic. Okay, thank you very much, Dr.
Abhishek, sir.
I came to your campus in person 3 times. Very nice campus. Hopefully to meet you next time, Pravesh, in person again when things are good. Okay,
Sure, sir.
so I'm given about half an hour. I'll try to complete.
Yes.
Mhm. Okay. This presentation was actually when we work with, especially when it comes to the pitching part, everybody, small enterprise will ask you what's actually data science all about, because if you're not part of the race, you're left out. But what is actually the main craze now? So though the pitching cost will be very less now because the competition is a lot, but at the end of the day, you end up having the same question from those people who are laymen, what's all about this data science. So let me give you why the race and craze, and with the have taught us a lot. Okay, so what was before? Why the race and craze, and why should or many consider, and what pandemic the new norm have brought, and the winding notes. Okay, during the industry age, early controllers are used to control machines. So during the early uh, 90s, all about electrical engineering and control. Okay, and it's all the control here. It's just to regulate power. So if you see the old power system in UK, it's all to regulate. Okay, so we move on to 19th century and we end up seeing two wars. Okay, it destroy a lot of human life, but it brought what a new technology that called as communication. When it comes to communication, it's all about active filters, and this war also brought mass production. In use, I think most of you know about ladder diagram and so on. It is still massively in use, and 98% of our industry now just still based on the PLC that they have seen before. So as we now look into the robotics for mass production again, I think in India we have a lot of auto industry, even near MIT campus. The PI and PID controller are still in use in many ways, and they are 100 years in existence. Okay, and these PLC logic are still what we call a knowledge that everyone like to know. Even now we are getting people to say, can somebody teach PLC? Because we go to countries like Singapore, some part of Malaysia where the industries are huge, PLC are needed in order to calibrate these machines. But the problem now is that these PLC are very control source. Okay, it is not an open Emerson Yokogawa is an oil and gas industry. So everything is closed source. So the whole idea now is how this operational technology or OT, we actually combine with IT. Okay, that is called information technology. So when information technology combined with OT, operational technology, that's where you get your IoT. So in this way, we can have the sensing, and this sensing is open for anybody to actually able to code and decode. But of course, it invite a lot of other things like cybersecurity and other issues. So what was before? It's all about trade, because without trade, uh, you are not going to make any money. So every country relate to GDP and trade, and the trade can be basics of agriculture. India are very good, big in agriculture, or services, or it can be any raw material or finished product. large records of clientels. It can be trade, or we call it retail customers, or business customers, or it can be just human client customers. All these are repetitive. Okay, all are repetitive. So we need computers to store, and we need some expert system to retrieve. So this was in the 60s. If you know about Unix system, HP UX, AS400, and our Sun system, which actually now is no more now. All these are part of that. Okay, so why the race and craze? Actually, it was there in 1910 when statistician doing the regression and classification. If you see all the algos for data science, it's already there for 100 years. But the race was that there's no race. But the initial race was with Fisher and Pearson. One was looking at correlation, another one looking at analyzing. And if you know that your LDA techniques until now, all these, there's no commercial values. Okay, there's no commercial values, right? But now, how to bring it to a commercial value? You don't need to enroll to specialized master's program now. Everything is free, data is free, knowledge is free, and you get new direction of knowledge by looking at all these freebies, YouTubes. You see, if I get a person from Assam, if you look at those video, he have a different view of that. If I get a guy from maybe Madhya Pradesh, he have a different view of that. That's the whole idea of Western countries when they have these PhD program. They like to take people from India, people from China, people from Malaysia. Let's see how they actually look at things. So now things are very open. Okay, you can do things easily. So data science algorithms are more of 50 to 600 years. Even if you see SVD is about 50 years old, the entire Google and Baidu search is still run by SVD code. Started when large bank, manufacturing company, or even logistics company like to mine and see how looking at customer rating. This company got large servers. Hey man, this company got AS400 are for multi-million-dollar company. Okay, HP UX used to be for large banking companies. So if you go to banks, you can see Sun servers or HP UX, or normally AS400. So it was these three companies were there, and now you can't see this much. These companies doing all these servers. And big airlines used to have what you call maintenance, and they have all the information in the server, and mostly are connected by expensive satellite communication. But now things change. These sites are no more. Why you need to have a server? You need to have those system administrator, which actually can be paying around like maybe a month of 3 lakhs a month for this system administration. Looking into those who are actually encroaching. So this is all no more. No server, no fans, no aircon, no system administrator. Everything is down in cloud and maintained by one person. But at the end of the day, it's cheap, but the privacy or information may be compromised. Okay, it was started in credit card business or e-commerce business. Until now, it is actually led by e-commerce service business. Okay, e-commerce, the biggest problem was a fintech. Now they call it authentication, the fintech part. That was until now people are improvising. Okay, with the web technology, the whole idea is easy due to money transaction, purchase, making bookings, and so on. And due to pandemic thing, this thing actually end up triple fold. Okay, and we have another one called social media, giving personal data. Social media, there was no income until they found that on text mining, and also social media look into registered user. Okay, so that's how things like YouTube, like Instagram, they're actually paying those people with many followers. Okay, but at the end of the day, anybody join in, you can see small ads which actually end up where they make money. All these customers willing to enter information stored in database, which are structured but not known where their geographical location. So that's how we call it cloud. When combining social media, text in and media. So it ended up to be unstructured. So these are the challenges for you to mine and so on. So best program you learn in school or college or YouTube, these needed big database information by analyzing the right tools. Okay. The whole idea is what you're going to do. If you look at the biggest companies, most of them are IT companies or e-commerce companies. So what they need, last time they will just hire their people and do the analytics. Now things and hold the programmer. The programmer leaves, the code is left. So there should be another guy or leadership struggle in order to hold those codes. Or if the code, another way is just pitching an open market. So this is why the need for the race for big data. Anybody can solve. Okay, and if you look at Yahoo is looking into the way of even looking at good students who are not completing their degree. They are giving them training for a short while, and they want to see things for their services when it comes to analytics and also looking at mining large data. So how do we tackle this? When it comes to machine learning, what machine will learn? It can be streaming from batch data or window data, or make machine learn using a set of code. So you need to know a little bit of statistics, and of course you learn as you go on. You need to know a bit of algebra, everything in matrix form. Even we go to large database, everything in file. Yes. The base guitar of machine learning is numerical method and unconstrained optimization or constrained optimization. Until now, that is the main thing that runs. If you want to see about gradient descent, BFGS, Leeuwen-Marquardt, everything is actually concealed. They will never tell you, but there are a lot of changes, a lot of improvement can be done that. So these are the things that can be considered. And now if you look at data science, it is already a saturation point. They're also looking at frequency domain, Fourier transform. They're also looking at things that, like curve fittings, spline. So they want to see things that they can improvise from what actually it is. Now you can code from a small PC. This is the whole spirit of data science connected to cloud. So if you have a Google Colab and also your Google Drive, you can have 3 GB data in Google Drive, and you can connect your Colab and you can stream whether offline using Hadoop or Spark, and you can do large. So this you can do, and you can possible before. You end up need to have be in, if you take 20 years back, you had to be in a big corporation, large server beside you, large what do you call microprocessor that actually able to deal that. And if if you use Google Colab, you just need to pay like what 300 rupees per month, and you'll give you a good Tesla machine for you to run. Okay, so I'm okay with the timing. So now what should you or may consider? If you had to look at what actually your interest is, whether you're in hardware, firmware, software, or so on. Okay, you take India. India is a giant when it comes to firmware. If not many people knew about it. They do a lot of programs for drivers. If you look at companies like Infosys, it's all about doing drivers integrated with microprocessors, and they have orders for more than 15 years. So where your stand is, are you going to be on a startup, or are you looking at user interface or data analytics business? And if you look at India and China, there's Alibaba. When it comes to India, there's Jio. These two have one of the largest e-commerce business in the world. Okay, of course, Amazon is so the Amazon India also are there. So now what I should or may consider, you should not just follow the flock. Okay, following a flock means you just, and when you hear somebody say, let's learn this, and you just go on learning that. Okay, think what is your interest, what benefits society around you. Start small, learn language of your choice. People say, Java is still there. If you like it, just follow. Just do what you like. Store your program in GitHub or any other cloud. Data available for test run. Okay, last time you can't get data easily. Now data, you have a lot of data for you to test. And pitching is open to, though the pricing is low. Okay, you can easily pitch now. by just putting up something in a pitching market. Okay, but on a small startup, there are a lot of startup actually they don't have enough programmer. They prefer to have those people actually working on freelance. Okay, pandemic and you know. This is what you see before pandemic. Anybody looking at the tradition of Asian countries, where the empowerment, looking at women empowerment, when our ladies always have a distance with the man, and our ladies normally cover their face, but the pandemic brought that thing to the whole world. So we never know that this will happen. Probably, our culture actually have learned this way before, and we never knew about it. Okay, so this pandemic have brought a new business, like what I'm trying to do now. Okay, all our information is stored in cloud, large servers, probably this one under 300 meters under sea, and most of the sea are cold, so you don't need to spend a lot on air conditions. So we need large data center to store video recordings and learning materials. And for now, normally people say the world is controlled by 2.5 company. So if you take Microsoft, it control an MS Team, Zoom, and also Google. So these are small companies now. And if you know about FLAC, fiber optic link, it's actually, they have a dedicated fiber optic links that actually cover around the world, like Microsoft, Google, Apple, and also Facebook. So big corporation house video calls, meeting on cloud, which large public and private servers. Big question will come is data privacy and cybersecurity. Where is your data stored? So anybody can actually compromise these data that you actually involve your very own self. And the best part of pandemic is time taken to work. Okay, remember that, no, always you go 9 to 5. Time to return back, no punch in, no punch out, drive and think, pollutions and casual discussion. So is this thing universities can think like, probably can come 2 days to work and 2 days, probably, you have classes and 1 day home. Okay, home, work from home, and this will reduce a lot of pollution, lot of traffics, and you need to pay 100 rupees per liter for petrol. Okay, so how are you going to serve these people? Are you going to create new working environment, or like big software companies in India like TCS, Infosys, they show double profits just by working from home? And what are the ways that you can think of that? Now, universities are thinking 1 semester in, 1 semester out, because probably, that can bring a new way of student lifestyle, that it reduce hostel needs and so on. Lockdown, no, we're not going to have a lockdown anymore. Insurance on wages. So more lockdown, we're not sure that we can get our daily wages. Mental fatigue, how long will be a lockdown? Advantage, we have family value, learn to clean your house, online teaching, learning yourself, thinking people who are locked in their life, those old people locked in their life, you should know that they can free them. You wanted to make change, seeing distress in life. Many people actually leave their job. They're doing good job, they leave their job, and they thought of seeing some new things to be done. Okay, there are a lot of new disruptive technologies, open banking, what do you call this, bitcoins, biometric security system. A lot of things now are there. If you want to ask me, the big thing is e-commerce and transport and banking. These are servicing. There's nothing there in raw material, or that's actually part of the trade. Big companies, big countries, they prefer seeing that trade is actually a cybersecurity. You have everything open. There are a lot of people with hooded look. They like to do things to leak things up and try to say, well, there is issue in your security. New norm brought e-commerce. There are big companies like Reliance. They do have huge e-commerce, and Amazon and Alibaba actually controlling for now. But the way it looks like, India also will play a big role in e-commerce. So that's a new norm that can be seen. My writing note is who made changes, where the changes or what makes the changes. If you do a quote and you want to really think of what actually you intend to do, think of these main things. Sorry, who made changes, where okay, chief and archive for future generation. These are the motto on every person who actually think of doing simple coding program. Okay, let me see. Okay, I'm going to finish in the last. This is my last slide. My writing note is humanize the journey where you quest for knowledge. Okay, in your path you meet all kind of individuals with colorful characters. I have one of the best data scientists. He opened up a small online shopping store and actually he sells Korean shampoos. Probably is one of the best coder that I have. But when I ask him why you're doing that, his answer is very simple. I earn more than a CEO of any company. So are you thinking that you want to go up there and wearing a tie and look smart and look always there colorful? Or are you thinking that, look, I want to make some changes to the society and I'll make some money? If you aim to be useful or beneficial to 1 or 2% who could be your parents, neighbors, friends, someone you never met, or someone or not in line with you, is beneficial, just providing a smile. So the whole idea is what actually you intend to do. Data science is a craze and lead you to a race. But what is the end game? You have to know that. Okay, this will create enlightenment to oneself. So enlightenment here is not a earthly heaven. Huh? Okay. So I'm just going to share to you, used to be the first billionaire Indian. Actually, he's a Malaysian guy and his son is actually a Buddhist monk. I think he have all these things in his life. Then he found that this is the best enlightenment to find. Okay. All right. Thank you very much, Prabhush Singh. Thanks for the opportunity. Since it's a half an hour presentation and sharing.
Thank you, sir. Thank you, sir. Thank you so much, sir. A lot of audience are from YouTube also, sir. So one question I have received from one of the student. We want to ask that, sir, what are the major privacy concerns when we are working in the research field of data science?
When it comes using Collab and you put your data, if it's a customer data, then it's a concern. Okay, but if your data that you want to play as a playground, then it's not a concern because it's in the open field. The reason is, if they give a customer account, they normally ask you to go to their own cloud and do the analysis, whether using Spark or Hadoop. But it's still, they like to see how you're doing it, because like insurance company, they have the name, the address, sometimes also the health concern. So you cannot be streaming it and doing yourself. And you need to tell the customer that I have to go through my cloud and do this. And they always ask, is a privacy breach may happen? It's hard for you to answer, isn't it? Because at the end of the day, a 3.1 gigabyte data, you cannot be running it in your PC unless you have a workstation, large question. If you put in any other cloud, for now, if an individual user, I do a pitching, I might put a Google Drive or Dropbox and I stream it, but it's still a cloud. I cannot be saying that it cannot be breached or shared data using Microsoft. So if it is a company or somebody giving you a data, just like insurance company, can you analyze and give me a pattern before you pitch, and probably I can consider. You cannot give a 100% answer that look, the privacy is or security is never be breached unless you do in your own PC, but it might take 2 weeks and you carry your results. Okay.
Thank you so much, sir. Thank you so much. for your enlightening words, sir. It was a pleasure to listen to you, give insights about this topic. We feel privileged to have your supervision backing us. Your talk was particularly insightful at time when the students are considering new ideas to broaden their knowledge for expanding growth in this field. I believe your words have set new levels of expectations that our students aspire for. On behalf of MIT University, Uttar Pradesh, Noida, I would like to extend my warm gratitude. Knowing how busy you are, we appreciate the time you took to impart us with your valuable knowledge, sir. We are highly grateful to you to have you with us, sir. Thank you so much, sir. Thank you, sir.
Thank you very much. Hope to meet you in person. Bye-bye. Thanks, everyone, and goodbye, Amity. Bye-bye.
Thank you. Good afternoon, sir.
Good afternoon. How are you?
I'm good, sir. I'm good.
Very.
Let's start, sir.
I'm ready to start anytime. Yes.
Okay, sir. Okay. So, good afternoon to all dignitaries, professors, participants present today. On behalf of MIT University, Uttar Pradesh Department of Computer Science and Engineering, MIT School of Engineering and Technology, I, Dr. Pravishek Singh, feel privileged to extend my warm welcome to one and all for keynote address for Confluence 2022, 12th International Conference on Cloud Computing, Data Science and Engineering. Even though we would have liked to invite you to our campus and have the keynote session in person, but current world scenario impede us from doing so, sir. Luckily, we are grateful to have the opportunity to keep keynote session in a virtual mode so that our students can reap the seeds from the knowledge gathered in the session. Today, I am profusely elated to take the opportunity to invite our honorable speaker, Jean-Paul Van Blair. Sir is professor in the Department of Information System at the University of Cape Town and director of the Center for IT and National Development. His research areas are the adoption and use of emerging technologies in developing world context, including mobile, cloud computing, open and big data. His passions are ICT 4D with a focus on emerging technologies as well as data for development in the SDG context and adoption of ICTs by small organizations. He has over 200 peer-reviewed publications, including 25 chapters in books and about 40 referred journal articles. He has been invited to give a number of keynote presentations at international conferences and holds an honorary professorship at MIT University as well. He currently supervises 50 masters and PhD students. Sir, we invite you on the platform to share a few words with us. Sir, over to you, sir.
Thank you very much for those kind words, Dr. Singh. I appreciate it. And it's nice to see you all. It is a pity I'm not there on the campus, but hopefully I will be visiting you on campus, I think early March. You have another conference.
Yes,
and I've submitted 2 papers. I hope that they get accepted, but I haven't heard yet. Let's hope that things in India work out as well as they did for South Africa with the Omicron virus, where we had relatively light rate in terms of infections and hospitalizations. I hope the same is true for you guys. It's really an honor to be back with you guys, everyone. And I hope your students are fully charged and energetic for all the offerings on this conference. And I'm gonna take away my ugly face and I'm gonna put my slides in place. If I can share my screen, it should be there. It should be fine. Can everybody see my screen?
Yes, sir. Now we can see, sir.
Okay, fantastic. So my presentation is really on I gave a couple of topics. It's based on research I've done with some of my students. And in this case, we're looking, since the conference is on cloud computing, we're looking at the adoption of cloud computing, as was mentioned. I'm very much into looking the social adoption of various emerging technologies. And in this case, we're looking at how cloud computing was adopted in South Africa in the oil and gas industry. And so I'm associated with the University of Cape Town and in particular with the Center for IT and National Development in Africa. So this is part of a larger research project. We've been looking at the adoption of cloud computing not globally and, in across all sectors of, and you'll see later on why that is so, but in the very specific sectors in South Africa. So previously, we looked at the investment services industry. We looked at cloud computing in higher education. We've looked at financial institutions, the banking sector, and we've looked even at small and micro businesses. So this we did last year was looking at the oil and gas industry, where adoption patterns were much lower. And so the research was mainly done by Shaheen Jamaluddin, who is actually working in the industry. He's an IT professional working in that space. So we're going to talk about, I'm going to give you a little bit in introduction and then talk about the gap, the research gap that we were following through, a very brief picture on the oil and gas industry in South Africa. Then what our key research questions are. Sorry, I've put my slides by mistake on auto forward. Okay, and then we look at the various factors that are influencing the adoption, conclusion, recommendation, and then I will look at how this fits into the bigger picture of cloud computing adoption. As you well know, in India, in South Africa, and then across the whole world, oil and gas is still very important in terms of fulfilling the global energy demand, even though we are trying to phase a lot of that out, but at least it's less polluting than coal. Which I think also in India, as in South Africa, is the moment the major contributor to electricity production, and I think the pollution. So oil and gas is actually a little bit more friendly, but hopefully green energies and potentially nuclear energy will actually reduce the footprint. So some of the benefits of cloud computing include that you have a reduced IT cost, you can adapt much quicker to changes in the marketplace or in your business processes. You can actually improve job training because you can easily transport your various virtual engines, images across. It's more scalable, it's more flexible, you have faster business reactions, so greater agility, and you can use real-time data. So despite all these benefits that everybody, and including you all have heard about the benefits of cloud computing at this conference, and you will hear lots more, some of the concerns that especially the oil and gas industry has is looking at the data security concerns, and specifically having very sensitive and very expensive data stored outside the firewall. Okay, the data that's collected by the oil and gas industry is much more expensive to collect than the type of data that's collected on, let's say, social platforms or in the financial service industry. If they do seismic surveys, those surveys cost a huge amount of money. Exploration surveys cost huge, and so that data is very, very, very important, and it needs to be guarded well. Disaster recovery, oil and industry needs to have full uptime. The data sets, the amount of data that they're working with, these seismic diagrams contain a lot of high resolution data, either sound waves or various electromagnetic sensor data. And so it's not just records like in the financial service industry or social media where you have textual data or numerical data. This is a lot of sensor data, and that takes up a lot of space. The high availability, poor bandwidth, South Africa, as in India, still has issues with that, although in the last few years, I think in both countries, we've seen amazing improvements in bandwidth provision. And then the fact that the oil and gas industry made huge investments already on-premise, meaning in-house solutions. They've got big data centers in-house. So, but these are technical concerns, and actually the bigger concerns seem to be the regulatory and the geopolitical issues that are associated with moving to the cloud. So we didn't find any research on the oil and gas industry cloud computing adoption in South Africa. And so we wanted to look at specifically what are the factors that drive the current adoption and future adoption in using these cloud computing technologies. So in South Africa, the petroleum sector is almost 10% of national GDP. yet it's not very visible. And so 3 big developments have happened in South Africa. The first was of northern Mozambique. We found a massive natural gas field, which is hugely, I think, larger than anything people have expected. Then in the Karoo, which is in the central area of South Africa, they've found huge deposits of shale gas. So that could be mined through the shale drilling technology. And then in 2019, they announced a gas find just off, we had moss gas here, but of this, in deeper waters, they found huge amounts of also liquefied gas under the ocean. And so, in fact, I know the very person who was actually involved. There was a few accidents. She actually is a French citizen, but when she comes on holiday here, her husband comes from South Africa and actually lives right opposite our house. So that was a sort of I think a small world scenario that we actually knew the person who was. She's a geotechnical engineer, and so she's actually been working on this data for about 10 years. So she knew long before it was announced to the public that there was significant gas to be found here. So, but you can see South Africa is a fairly large country. So this is about 3,000 kilometers across from Cape Town, where I'm calling you now, to pretty much the opposite side here. So actually, so sort of more like 2,000 kilometers across. And so this is the central region that we're talking about, where the shale gas is being found. You can see where the various exploration areas are. As you know, the green movement rightfully is very wary about allowing this shale drilling to happen. And we also have what is called the square kilometer array, which is a very sensitive astronomical instrument looking, and so they also don't want seismic activity to impact the survey instrument. So there's lots of reasons why we should have. So of northern Mozambique, which is not plotted here, there's been found a huge, that would be on the northeast corner. So towards 1 o'clock of this picture. But so all of these green areas are exploration. So we're very lucky that we have a long coast like India. But I'm not quite sure whether India has got these same shale deposits that we have, or liquid gas deposits. Do watch my time. I know I have not too much time. So basically we wanted to look at, is cloud computing at the moment being adopted? Because we haven't heard anything about the oil and gas industry using cloud computing technology. And then how would these, what factors drive this adoption, and what challenges do they experience within these? So what we've used here is what we call the TOE framework, Technology Organization Environmental Framework, where we classify factors, and we actually already have lists of factors under each of these factors. And we'll go a bit further on these. But yeah, so typically, if you look at the TOE model, there's certain factors that typically adopt. That's an organizational adoption, as opposed to individual adoption, where you may be familiar with terms like UTOUT and TAM, the Universal Technology Use and Adoption Framework, and technology adoption model. Okay, in this case, we're looking at organizational adoption. So you can group a list of factors under technological factors, and the organizational factors, and environmental factors. And so it's a nice framework to classify and to have a starting list of factors, which normally gets supplemented by factors that you find in the literature. Okay, so it's an empirical, so we call this the research onion when you embark on a social science study. I know a lot of you are engineering or computer science backgrounds, so to you, the social science paradigms are a little bit difficult. But first, you typically look at your philosophy. You start, what philosophy have I got around how knowledge is created, what type of knowledge exists? And so as a computer scientist, probably, or any science, the natural sciences typically have a very positivist view of the world. But the further you move in towards philosophical or humanistic sciences like sociology, psychology, you become more subjectivist, maybe interpretivist. If you want to change the world, you become a radical humanist or structuralist. So, engineers tend to be quite pragmatists and computer scientists. Then the approach, you can either work from a deductive paradigm or an inductive paradigm. Inductive means that you let the data speak and you derive theory from that. Deductive means you have a theoretical framework and you use that model or that framework or the theory you have in terms of trying to explain what you're seeing or trying to analyze what you're seeing. In this case, we use a combination because we've got that technology, organization, and environmental framework, but we realize that the factors that go into each of these dimensions, we don't know that much about. So we did this survey. The survey is not by means of a questionnaire, but actually by means of interviews. So we only used one method. We didn't use a mix or multi-method approach. And the study was cross-sectional, so we just looked at one particular point in time, as opposed to tracking a phenomenon over various dimensions. So if you're going to be doing research, look at this research onion and make your decisions. You can choose depending on the problem, but also depending on your background and your personality. Like in this case, we could have, instead of a positivist approach, we could have used an interpretivist approach as well. But we didn't really want to go there. So we interviewed people at 4 different oil and gas companies, 2 international ones and 2 South African owned companies. And there's only really 6 oil and gas companies in the whole of South Africa. So the people that we interviewed were actually quite leading, with lots of experience, high up, very knowledgeable about cloud computing, and they all had more than, sorry, that should not be less than 2 years, should be more than 2 years of cloud computing experience. The other 2 companies did not want to participate with the survey because they've perceived to be quite sensitive in terms of information. So all of the companies, as you can see here, the OG oil and gas company 1, 2, 3, 4, they all have implemented cloud computing. They all use software as a service mainly in terms of collaboration, communication environments. The models that they're using are typically not, apart from software as a service, they don't have a physical infrastructure cloud deployment that they develop themselves, except for one company who's got a private cloud. But in terms of going forward, all companies indicated that they would not make use of a public cloud. They would use a private cloud infrastructure for their future needs. So in terms of the plans, you can see here, all of them, all companies have developed here. There's some quotes here. Although they do find that there's a lack of maturity in terms of the offerings available in the cloud computing industry. So a lot of cloud computing vendors, like the Amazons, like the Googles, like the Amazons, IBMs, they focus on the financial markets, businesses, small businesses, manufacturing, but they actually don't really have got specialized offerings for oil and gas. So you can see here, OG4 is actually quite advanced in terms of using electronic cloud content management systems and so on to port their content and to share and collaborate with their, not only in-house, but also with their vendors. So there's a positive attitude. They've started experimenting all, but they haven't fully gone on board with cloud computing. So we're talking 2021, last year's that this research was done, and still a very low level of adoption of cloud computing in this sector, as opposed to the financial services sector, as opposed to which is hugely in cloud computing. Manufacturing is hugely in cloud. Even higher education is using a lot of cloud services in South Africa, but not the oil and gas industry. So if you're looking at some of the factors that drive this, relative advantage, meaning is whereby one company is gaining competitive advantage over another company. And you can see here the benefits that the cloud services give is in terms of deployment, manageability, maintenance cost, and flexibility. And you can see here examples of each of those in quotes where companies give specific benefits. Another technological factor is the compatibility with existing infrastructure. And there, even though cloud vendors have done quite a bit of work, you can see that there is a little bit of an issue that a lot of legacy applications don't give or are not that compatible with what's available in the on the cloud computing platforms. Complexity is also an issue, and the complexity lies not so much in the complexity of the cloud offerings, which is normally the case which you found in other industries, but here we find that the complexity of the adoption is much more involved with transferring the existing systems into the cloud, the legacy systems. So but they found a lot of support. So the vendors are giving a lot of support to companies wanting to move into the cloud, and that is actually seen as a big benefit. The most negative impacting factor, all the previous two were positive ones, the negative one is the security concerns. And so because particularly around the data, not so much the process, business processes, but the data, is a big perceived issue in terms of putting data out there in the cloud. Although some people do realize that security can actually be better sometimes enforced in the cloud than in your own data centers. Because the cloud vendors obviously have to make their reputation is fully dependent on the fact that they are, they have to be secure. So their reputation hangs on it. So actually, a cloud computing vendor will probably have much better security protocols in place than you could almost provide at any one local company. So I think that's an important thing to realize. So in summary, we have three driving positive factors: compatibility, relative environment, security, whereas we have one drawback, the perceived complexity and the issue around that, which could be negative. In terms of organizational factors, in previous studies, we found a whole lot of organizational factors influencing, and I'll come back to that later on a little bit. But here we found that top management support was actually a critical, and top management did support us. The organizational readiness, how ready is an organization? Again, the oil and gas industry showed that this is a very important factor. They agree with that one, but they didn't think that was going to be a major obstacle. And so the organizational factors did not preclude the adoption of cloud computing. The biggest hindrance in terms of adopting cloud computing are the environmental factors, so the government and regulatory compliance. And so the fact that we have a Privacy Act, the POPIA Act, is there, but that's not a major issue because it's not so much the information about the customers that they were trying to put into the cloud. It is more about where must data be held, how sensitive is the data, must be staying within the borders. And the South African government is busy formulating another policy, quite a far-reaching policy around cloud data. So another factor is competitive pressure. At the moment, even though there is lip service was paid to this, I don't think the companies are actually experiencing a lot of competitive pressure to move into the cloud because it's not very visible. They're not necessarily competing for customers, so the view is not that critical, but it does play a role. And then vendor support was very important. I mentioned that earlier on. So both in terms of service level agreements, but also in terms of training and accommodating migration issues and so on. So summarizing these, vendor support, government regulations, even though there was some insecurity about where these are going, were all found to be very important for the oil and gas industry. So cloud computing has been adopted in the oil and gas industry, but it's very tentatively. I think they're exploring it at the moment. So unlike other industries, the level of cloud computing adoption is pretty low. And here you're talking about an industry that accounts for almost 10% of the GDP. So these companies are hugely technology driven. They've got huge capitals, and yet they're not adopting cloud computing as a lot of other industries would be seeming to do. And so we talked about these factors. Now, what will be interesting is actually to compare some of these factors with what we found previously. So before I do that, there's a couple of recommendations here, but I see I'm slowly running out of time. So I'm not going to talk about the recommendations because these are specific to the oil and gas industry decision makers, which probably are a bit less important to you as students in India. And I do admit that this is fairly small sample size, but the industry is a very, it doesn't matter that if you do this type of research, it is not whether you get 50 respondents or 1,000 respondents. The criteria for the number of interviews you need to hold is actually your data saturation. Have you collected the data that you need? And that's, if you have that data, then basically it doesn't matter how big or small your sample size is. So in this case, we've got we're fairly confident that we had a comprehensive view of what was really happening in these companies. So, I'm not seeing that as a big issue. The other thing is that the interviewees were all men, all male, and sadly, still in the oil and gas industry, that is the case. Although I must say, my neighbor, who did actually work with this exploration, she's female. She's a French woman. So now I want to compare this to a presentation I actually made at Confluence a few years ago, where we looked at cloud computing readiness in the financial industries. And that was done about 6 years ago. And I'm not going to go through the data in detail, but I want to come up with the findings where we developed a framework for how to adopt in a particular industry or organization, how to adopt and look at the adoption of cloud computing. And basically the elements of the framework were that one of the important things to do is look first to a impact and suitability analysis. Is cloud computing important for your organization? Then look at the various factors, technology, organizational, environmental factors, and you can see the factors that you found in the financial service industry were much more comprehensive, but quite different from the ones we found in the oil and gas industry, which precludes you from actually developing models for all industries in South Africa or India for that matter, because you'll find there's different factors for different industries. Oil and gas is very different from financial services. You can't have just one model to try and explain cloud adoption in a country. Okay, and those factors then determine usually the adoption and implementation, but sometimes before if you haven't adopted yet, you first can assess your cloud computing readiness. So we got another factor, assess your readiness first before you start adopting and implementing. And all that would be driven through a change management framework. Okay, and I can spend maybe a few minutes, I don't think I have too much time here. But so your change management framework, look at the impact, do an impact suitability analysis, then assess the factors, then look at your readiness, and then go into implementation. And so the impact and suitability analysis, look at those areas where it may make a high impact and where you have high suitability, whereas where it makes a low impact, it doesn't really matter. Sorry. Apologies for that. Okay, we don't want this type of impact that you see here on the left. Okay, and so the factors, as you can see, were very different to what we discussed today. And then finally, if you do decide to implement it, then you must implement this change management. And if you look at Cotting and Schlesinger, you can see there's different ways of enforcing change management in an organization. And I'm just putting this in here because you'll find any technology, a lot of you love technology, but then you fail to understand that in an organization there's often lots of resistance in terms of adopting technologies. And these are some generic ways, either educating or participating in the decision-making process or facilitation or negotiation, or if all fails, coercion. And you can actually try and find out, as a student in a university, what methods are they implementing in terms of you, if you have to adopt a new process or a new attitude or a new way of learning or whatever it is that your professors are trying to do in your organization. So thank you very much. I think I've just managed to stay within time. And I must applaud you for starting on time as well. So anybody who's got questions, I'm not sure if we, Dr. Singh, if you have time for questions now, but you can also.
I have few questions. Actually, a lot of audience is listening to us, listening to you on YouTube as well. So I have received one question from one of the student. Although you have covered this question in the PPT, please answer. This question says that what are the major cloud strategies that we have to take care when we start our research in adoption of cloud computing in our country, India? Please share main key points that we focus on.
So in terms of research strategies or in terms of the organizations doing the cloud computing? In terms of research strategies, I think that's an excellent question. And so if I may go back to that slide where I looked at the onion. Okay, your first, there's the scientific aspect, which is choosing a methodology in terms of, what type of knowledge do you want to build? What is your feeling, attitude towards knowledge? And then you make these decisions, the formal decisions of the typical research methodology determination. Okay, and there I refer to any textbook on research methodologies. So that is your one important focus. Okay, and that's what they teach you in your research methodology course. But I love this question because in the real world, things work very differently. And so if you're going to do, as a student, pick a topic and you want to research cloud computing, some level of adoption in India, I think there's two very important decisions you've got to make, or actually maybe three. Okay, first of all is who in your university is going to supervise you and who you're going to work with. And you want to work with ideally a mentor or supervisor that has got a particular affinity to the research problem that you want to investigate, so that you feel but also that you can develop a comfortable feeling with, that you feel you can collaborate, that mentor is not going to exploit you, is going to make some time for you, and so on. So that's one practical decision. Then the other decision is do some research that you can sell in terms of your career prospects. So it's no use doing some esoteric topic that is not going to give you a leading edge or an advantage or a one-up. If you want to go work in the cloud industry or the IT sector or in the financial services sector, then try and focus your research there, because when you do your research, both you're going to develop a network of people that you can work with or that you maybe can apply to, that get to know you, and also you can sell at a job interview. You already know and you can demonstrate that you've got some knowledge of the industry. And the third one is that you need access to good data, because your research will depend on good data. And in this case, if you're looking at adoption of cloud computing, you need access to empirical data. And so you need to make the decision, are you going to investigate corporate environment or individuals? Are you going to be looking at the cloud adoption by academics, by medical professionals, whatever it is, or are you going to look at certain organization types like oil and gas industry, which you have very little of in India, I believe, but financial services, IT industry, small businesses, maybe geographic region, maybe government, whatever it is. And there, the key will be how you're going to find your respondents, whether you send out a survey or interviews. So these are three pragmatic criteria. Okay, who in your organization at the university is going to supervise you, and can you work with him or her? What is the nature of your relationship, both professional and on a personal level? 2, is your research going to be marketable and help you with your job interviews? And 3, will you be able to collect your data? That's what I would do from a pragmatic point of view. But a great question. Thank you.
Thank you, sir. Thank you for your enlightening words, sir. It was a pleasure to listen to you, your insights about this topic. We feel privileged to have your supervision backing us, sir. Your talk was particularly insightful at a time when the students are considering new ideas to broaden their knowledge for expanding growth in this field. I believe your words have set new levels of expectations that our students aspire for. On behalf of MIT University, Uttar Pradesh, Noida, I would like to extend my warm gratitude, sir. Knowing how busy you are, we appreciate that the time you took to impart us with your valuable knowledge. We are highly grateful to have you with you, sir. Thank you so much, sir. Thank you, sir.
Thank you, Dr. Singh, and good luck to everybody at the university that was listening to me. And it's been a pleasure and an honor. So I look forward to seeing you guys soon again.
Thank you, sir. Sure,
Maybe
sir.
next year or otherwise in March.
On March. Yes,
Okay.
sir. Thank you, sir.
Goodbye.
Bye, sir. Bye. Bye. Thank you, sir.
Good afternoon, sir. How are you?
Fine, good afternoon. How are you doing?
I'm good, sir. I'm very happy to see you.
Me too.
Yes, sir. So, sir, I want to introduce you, then you can start your talk. Okay, sir?
Sure.
Okay. Good afternoon to all the dignitaries, professors, and participants present today. I will introduce Vincent Puri, is a full professor at University of Milan, Italy, and he is also department chair. He was associate professor at the Milano University, Italy, visiting professor at University of Texas at Austin, USA. He was a visiting researcher at George Mason University, US. He founded a startup company, Sensor SRL, in the area of intelligent system for industrial applications, as well as very active in industrial research projects with several companies. His main research area and industrial application interests are intelligent system, computational intelligence, pattern analysis and recognition, machine learning, signal and image processing, biometric intelligent measurements, industrial applications, distributed processing systems, IoT, cloud computing, fault tolerance, and many more. Sir, we welcome you here, and I request you that please start your talk.
Thank you. Ladies and gentlemen, good afternoon. Namaste. It's really a great pleasure and an honor for me to be here with you today and talk about the use of artificial intelligence in the advanced infrastructure for cloud, fog, edge computing, and Internet of Things. In particular, today what we are going to see is how we can actually use the artificial intelligence both to create applications as well as to manage this infrastructure in an efficient way. As you know, the cloud infrastructure are a set of components which provide the basic computing, storage, and networking facilities, as well as more advanced functionalities which can be the base for a broad variety of applications, including databases, queue management, runtime support, identity verification, and so on. And they provide also some components which are typical of many applications so that we can reuse these services, these components, without having to create them from scratch. And these systems are very useful since they allow to reduce the cost we pay exactly for the resources that we are using, and they provide a significant continuity of service with managers, with operators, which are specialized in the various aspects of managing this infrastructure. And as a consequence, the quality of the service can be significantly high. In the modern scenarios, we have not only some big players which provide these basic services, but we have also some other players which are providing specialized components, specialized services, specialized tools for very specific application areas, but with a very relevant contribution from the technical and application point of view. For this reason, more and more on the market, people started to use a multi-cloud environment, choosing where to deploy the various components. In this kind of scenarios is the customer who has to split the application and deploy it in the various clouds according to the specific needs. More recently, we have what is called the Cloud Federation, in which centrally we have a broker which take care of distributing the various components on the specific cloud where these are offered. And as a consequence, this central broker will take a significant effort in optimizing the distribution of the various needs of our application on the appropriate cloud infrastructure, which is participating to the federation. The modern applications are generating a significant amount of data. And in some cases, the bandwidth from the peripherals to the cloud may not be sufficient to bring the entire data from the peripheral directly to the application which is running in the cloud. And this may prevent the real-time operation of our applications, especially when real-time is very, very strict. For this reason, what has been introduced is the fog computing model, in which we move a part of the storage and computation nearby the peripherals in an area which is grouping several of the peripherals, so that only the local connection may be overloaded by the significant data transmission. And then to the cloud, we are sending only some compacted information that has been obtained by merging the essential information provided by the peripherals. If the application is really generating a massive amount of data, what we can do is actually to move a part of the computation and part of the storage attached directly to the peripherals. And this will really significantly reduce the amount of data, extracting only the relevant features which are needed to be transferred to the central application in the cloud. And this creates a hierarchical structure with the peripherals, the edge, the fog, and the cloud infrastructure. On the other side, the Internet of Things is a modern infrastructure which allows to plug in our peripherals, our devices, our systems, using standard interfaces and protocols, so that it will be much easier to connect these devices to the system and have the flow of data moving to the servers where the applications are running. The basic advantage of the Internet of Things is the fact that it is a modular infrastructure, is a standardized a set of interfaces and connection, which allow to support in a flexible way the applications. And the introduction of this model in conjunction with the cloud allow to have an infrastructure, an heterogeneous infrastructure in which we have the peripherals, the various devices connected according to the Internet of Things model by exploiting the flexibility of the standardization for the interconnection and the protocols. And then we may have eventually the fog and at the end, the cloud infrastructure for the final storage and analysis of the relevant data. When we have this global interconnection, the dependability and the resilience are very important, since we do want to ensure the continuity of service for our applications. And it is important also to have dependability to ensure protection from possible external threat, for possible malware, and ensure the privacy of the data that we are managing in order to better support our applications. But let's see how we can use the artificial intelligence in this type of infrastructure. There are many companies which are investing in this direction. But what we can see is that several of these companies are providing tools which allow to build our applications from the analysis of the data to the generation of the specific final goal of the use of artificial intelligence for classification, clustering, prediction, control, and so on, in a black box, in a tool, so that we do not really need to have a detailed knowledge about how these technologies are working, how they need to be configured, but we may have a set of tools, a set of functionalities in the tools which are taking care of this, and we just need to understand the general structure, the general operations, the general goals of these tools, and provide the appropriate information for configuring the tool and running the operation. And these tools can cover both the subsymbolic artificial intelligence, which is called also computational intelligence, like the neural network, fuzzy system, evolutionary computing, deep learning, and so on, as well as the symbolic manipulation of the data, the symbolic artificial intelligence, in which we have rules which describe the reasoning and the generation of the ultimate knowledge that we are interested in. Many companies are also providing basic services that can be put together to build our application. We have services which take care of collecting the data, cleaning the signals and images coming from the sensors in an appropriate way. We have services which allow to collect the data, to store the data appropriately according to the type of data. And we have also many services which are more specifically based and focusing on the exploitation of artificial intelligence techniques to extract the knowledge with machine intelligence techniques or to build models for our data. We have also components which allow to build the application with a much more natural interaction with the humans, for example, with touch, speech, vision, and so on. And we finally have also some companies which are offering a group of services specialized for specific use cases in a variety of application areas, so that we can reuse these use cases if they are matching enough with our needs. And then we just need to tailor some of the parameters of these use cases. Finally, we have some companies which are providing verticals covering the entire spectrum of the needs of some applications. And if our case is if our industry is within this application, if our service that we want to provide to the ultimate customer for health services or government applications are falling in these vertical areas, we can use the entire set of components offered by this company. And we have other companies which are providing the data mining and data analytics tools to extract the knowledge from the data as a general infrastructure for analyzing massive data and extract the knowledge, for example, by using ontology or semantic rules. Data analytics systems allow to collect the data, have appropriate modules which allow to collect the data from heterogeneous sources, storing this data in the most appropriate repository according to the type of data we are collecting. We may have data which can be stored in database systems. We may have non-SQL databases and so on, according to the specific type of structured, semi-structured, or unstructured data that we are collecting. And then this data aggregation layer allow to describe this data, allow to define how to store the data, how to extract the data for the subsequent analysis. The analytic layer will allow to extract this data, digging in the repositories in which the data have been stored, and create views, map the data appropriately, compress the data, and extract the knowledge which is embedded in this data. Finally, we have the layer which allows to explore the knowledge which has been extracted in different ways. We may have visualization reporting tools which allow to observe the information that we have extracted, the knowledge that we have extracted. And when the data are really massive, we may need to have a monitoring, a real-time monitoring system which point out the critical situation and attract the attention of the operators. Finally, whenever we have to analyze the data, extract the knowledge, and based on the knowledge, take decisions, we may have some decision support systems which provide some basic information, some general views of the information that we have extracted, some views of the knowledge that we have built from the data, so that we, as a decision that need to take a decision in a specific application area, in a medical system or in environmental application or in manufacturing, having this guidance extracted from the data, we can reason and take, based on our knowledge, on our experience, on the information and knowledge that we have collected from the data, we can take the most effective decision. And the cloud has been really a facilitator of the use of artificial intelligence, both in providing tools, components, and providing hardware support for the very massive computing problems. Internet of Things, on the other side, can be viewed as a distributed intelligent processing architecture when we deploy the artificial intelligence components in the various processing entities near the sensor, near the sources of the data, and in general in the infrastructure. But the artificial intelligence can be used also to manage in an effective way the infrastructure, not only to build the applications. And there are many, many opportunities for doing this. For example, when we need to choose a service to be used, we need to define a service level agreement, specifying which are our needs, which are our constraints, the preferences, and so on. And fuzzy system has been shown very effective in this perspective. On the other hand, machine learning has been very effective to extract the knowledge from previous cases that has been observed by the cloud provider. When we need to select the cloud or in a multi-cloud infrastructure to deploy our components, we can use in an effective way the artificial intelligence techniques, in addition also to many heuristic techniques. But the advantage of the artificial intelligence techniques is that we can specify, for example, with the fuzzy system preferences and needs in a much more flexible way, nearer to the way of the user that they have in expressing by natural language the characteristics. On the other side, we can exploit the neural networks and other machine learning techniques to extract the knowledge, to perform the selection, to learn from the data that we have collected in the past in order to take the most appropriate decision. And evolutionary computing and machine learning can help in multi-objective optimization. When we have chosen the various multi-cloud, we need to distribute the various components of our application in the multi-cloud and in the cloud federation. And artificial intelligence has been shown effective also in this perspective. In the modern application scenario, the applications are built especially by putting together some basic services which are provided in the infrastructure. And also in this case, artificial intelligence has been shown effective both for defining the needs to perform the match and choose the most appropriate composition of the services. When we have identified the virtual machines on which we wanted to put our components of the application, then we needed to deploy the virtual machines in the cloud environment, attaching the appropriate resources to the various tasks. And also in this case, the artificial intelligence has been shown effective for the mapping and for the specification of the resources. On the other side, when we needed to move the virtual machines in the cloud, we needed to perform another type of mapping. And also in this case, artificial intelligence has been shown effective. When we needed to manage the distribution of the computation, we may need to take into account the fact that the cloud the node in the cloud may be overloaded, and as a consequence, they may not be able to perform as we wish. The prediction of the behavior of the various components and the prediction of the workload in each node allow to point out these critical systems, this critical situation, and start the appropriate reallocation for rebalancing the load distribution. In the Internet of Things, we have similar problems. We need to allocate the resources to the Internet of Things function and task, and to allocate these resources to the infrastructure. Also in this case, artificial intelligence has been shown effective to specify in a flexible way, in a natural way, the needs and to perform the mapping. And also in the Internet of Things, the prediction of the behavior of the task and the workload has been shown successful in order to be able to reallocate eventually the workload, maintaining the efficiency of the entire infrastructure. This is very important in order to have dependability for our application whenever we have an imbalance. But it is important also to consider the fact that the management of the energy, saving of the energy is very, very important, and is more important nowadays and in the future, since we need to run our services at the lower use, with the lower use of energy. Why? Well, first of all, this will allow to reduce the cost of using this type of infrastructure. And on the other side, this will allow also to reduce the impact on the environment, on the natural environment, reducing the need of generating electrical energy, and as a consequence, contributing to reduce the pollution and the impact on the climate. We need also to consider the need for optimizing the overall infrastructure, having sufficient redundancy to ensure the continuity of service at the appropriate level. But we need to take this into account also in the case of faults, since we need, as I said at the beginning, we need to ensure the continuity of service 24 hours a day. This implies that we need to detect the fault, and whenever we have a fault, we need to reallocate the computation in order to have a continuity of service for our users. And in order to act in advance, we can also have a fault prediction in the system, so that we can start the reallocation before the fault occurs, when we know that there is a significant probability that the component became faulty. The security is also another very important aspect in this kind of infrastructure, and the detection of intrusion and malware can be performed in an effective way by using artificial intelligence techniques, analyzing the logs that we are collecting in the operation of the system. Trust management is very important as well, and can benefit from artificial intelligence whenever we need to ensure the trustability of the infrastructure that we are using, of the part of the infrastructure that we are using, in order to guarantee the quality of the protection to the application. And finally, it is important also to be able to analyze the possible threat, to analyze the vulnerability of our architecture in order to make sure that when we deploy a very critical application, that is deployed in a very secure area. And artificial intelligence has been shown very, very effective, both for the detection, the analysis of the threat, and the prediction of the security level, of the vulnerability of the system. When we have this kind of very complex infrastructure, it is important also to be able to monitor what is happening in order to alert the operators very quickly. And it is very difficult to have all this data analyzed by a human. For this reason, it is very important to have a monitoring system which collect this information about the critical situation and provide a concise view to the managers. For cloud fog and Internet of Things services, is also important to use the artificial intelligence to have a very flexible, smart way to set the pricing, to predict the market behavior, in order to make sure that we are providing the service at the minimum cost in order to attract many more customers. And on the other side, to provide a sufficient remuneration in order to support the investments which are needed in the infrastructure and the remuneration of the initial investment for building this type of infrastructure. So the contribution I like to give to you in this very concise overview is the fact that more and more our application needs intelligence, and the complexity of the cloud infrastructure as well as the Internet of Things need smart approaches in order to achieve the most effective management of this infrastructure, in order to extract the best from this infrastructure. And artificial intelligence has been shown very effective in order to create smart applications, but has been shown very effective also to provide additional tools for managing in a flexible way, in an adaptable way, extracting the knowledge about the management directly from the real situation, enriching our own knowledge that we may have achieved by analyzing many cases in our activities. With this, I would like to thank you for your kind attention. And if you have any question, I will be very happy to answer. Thank you.
Thank you so much, sir, for your enlightening words. It was a very pleasure to listen to you, having insights about fog computing, edge, and many recent research areas. And we feel privileged to have your supervision backing us. Your talk was particularly insightful at a time when students are considering new ideas to broaden their knowledge and research areas. I believe your words have set new levels of expectations that our students aspire for. On behalf of my university, MIT University, Uttar Pradesh, I would like to extend my warm gratitude towards you, knowing how busy you are, but I appreciate the time you took to impart us with your valuable knowledge. We are highly grateful to you with us. Thank you so much. Many thanks to you, sir.
Thank you. Namaste.
Namaste.
Good morning, Deepak.
I am audible.
Yes, sir. Yes, you are audible.
Dr. Deepak God, I am audible.
Yes, sir. Yes, sir. Good afternoon, sir. You are audible, sir. Sir, please start, sir.
Dr. Deepak God, I am audible.
Yes, sir. You are audible. Dr. Roshan Lal, sir, you are audible.
Yeah.
Please
Okay,
continue.
Okay. Okay. Thank you, sir. Thank you.
Right.
Thank you. Good afternoon to all the dignitaries, professors, and participants present today. On behalf of Amity University, Uttar Pradesh, Department of Computer Science and Engineering, Amity School of Engineering and Technology, I feel privileged to extend my warm welcome to one and all for keynote address for Confluence 2022 12th International Conference on Cloud Computing, Data Science and Engineering. Today, I am happy to take the opportunity to invite our honorable speaker, Mr. Haru Mehra, CEO and President of Project Lee Friend under the patronage of a Indian Embassy in Paris and Project Head University of a Grenoble Indian subcontinent. Sir has contributed diligently in the field of coding camps and internship opportunity for Indian student in Europe. Sir, we invite you on the platform to share a few words with us. Please, sir, you are most welcome, sir.
Thank you very much. I think it's good morning for me, but it must be good afternoon for you. So I am right now in this beautiful city called Lyon in France, which is very close to the University of Grenoble, which is our which has a MOU with MIT University, and we did many programs with the MIT and I'm happy that many students actually benefited from our programs, which were conducted and signed by under the leadership of Dr. Gurinder Singh. So actually, I would like to my viewers today to let them know that how, because you are all engineering students, and part of the world, the most of the world is moving towards digitalization, and it has already moved, and there are so many opportunities which are available all across the world in this new economy, which is based on coding. So as a educationist and as a person who has been in this domain for the last 20 years, I have been fortunate enough to create programs not only at the level of school, but also at the level of university to promote this new way of actually work, which is basically the new economy, as we call them. And as things are moving towards Internet of Things and the online and everything which is related to the new economy, it is very important that that students right from the school level, they know about it, and the government of India realized this, and that is why you must be knowing under the new education policy, it is mandatory to learn the coding from 6th, 7th and 8th class. So 6th, 7th and 8th class, it is now being made mandatory to learn coding. And so I will first part, I will tell you what we are doing here based in Europe to help India to to learn this aspect aspect, and also what is it that is there for you as engineering graduates, as undergraduates, as people who will just graduate after a year or so. What is the opportunities that are available to you in Europe to integrate yourself, not only to find the new job, because there are jobs available here. In fact, there are not enough people who are available here, and that is why there are a lot of Indians. Like I'll just give you an example. 2 days back, I was in Helsinki, and I was in a restaurant, in fact, a Nepalese restaurant, and there were a lot of Nepalese students there who were actually eating and having some birthday party. And I told them that, are you students? They said, no, we were students, but now we are working. I said, where are you working? They said, we are working with Nokia in the cybersecurity division. And we said, okay, where did you study? They said that we studied in India. So they were Nepalese student, came to India in a university like MIT or other university. They studied their engineering. They did 4 years or 5 years or 6 years of masters and all that. Then they got an opportunity in Nokia, and now they are celebrating a birthday of with the 10 to 12 students of Nepalese origin. So imagine that the opportunities which are available here in this domain. So we want to tell you a bit about that, but before that, I would like to share my screen and show you how we are actually promoting this aspect. So I was in Finland to do a tie-up with a future skill camp. As you can see, can you see, Deepak, can you see my screen? Mr. Roshan, can you see my screen where future skill camp is written?
Yes, sir, I can see your screen.
Okay, good. So this is, as you can see, is a future camp, skill camp, which is for the kids, for the school students who are 14, 15 years old, that we have created. And what happens is that we do programs like we have a coding Olympiad in India, where the winners, and there are winners from all over the world, those students who are in the school, they actually learn coding, and the one who wins them, we take them to Finland. And this is a coding camp that we take them to. What they do there, they learn coding and robotics while building skills in creativity, critical thinking, communication, collaboration, and computational thinking. So no matter what the future brings, students will need such as abstraction, problem solving, design thinking, finding and applying knowledge, and entrepreneurial skill. These are the things that we let them discover at a very young age. So I will in fact maybe share this presentation with MIT later, so that they can actually share with you. This is a program that we are doing in the north of Finland with the region called Oulu, and which is actually the birthplace of Angry Birds. Like, I know in today's generation you might be playing games with Fortnite and all that thing, but you just go 10 years or about 10 years back, then there was this Angry Birds, everybody was playing Angry Birds, and that is the headquarters of Angry Birds. It is actually the region of Oulu in Finland. So we are doing it there. A program goes like say for 4-5 days, where each day we have right from the introduction to the team presentation, the project plan, whatever is the students are given a project, and they are guided, and they need to develop that program. And be it game design, or be it innovation in technology, or and even we have tied up with the Lego group. Lego Group is doing. Lego is a company. It's a Danish-based country. It's also a Scandinavian country, Denmark-based country, and you might be when you go to a big store mall in India, you will find a Lego store. So those people we have tied up with, and they are helping us in coding with microbit and microbit electronics, intro to like the machine robots, and all that program they have actually helped us develop. So this is for the for at the school level. Now what are we doing and what do we have at the university level? Now at the university level, I would like to present this presentation which my colleague who is a METN, Mr. Abhishek Nandi, who is working with us, has actually made. And this is a MET summer internship for the engineering and robotics students in Europe. Now, this program is conducted under the patronage of the Indian Embassy in Paris. And what are the important points? Okay, so I will just probably can you see my full screen, or is it a problem in viewing because of the
Sorry, it's fully visible.
Okay, good. So the important points of this internship is of 30 days duration. You will not have any problem with visa, accommodation, pickup, drop, and because that is being arranged by our partner institutions in Finland and in France. So it is available. You choose the country. It is available in France. It is available in Spain. It is available in Finland. So all the three countries, this program is available. So how does it go like? Like, for example, I'm talking to you about France, the program that we are doing in Lyon. So we basically say you want to come in May 2022 because this program has already been mailed to your international department, and maybe it will come as the things are more okay in India. So you pick up at the Lyon International Airport, which you check in your residency. We will be briefing you on the international internship program at our office. Project overview by me and Claire, who is actually taking care of this project, and by the local industry, which is the Chamber of Commerce here in France. The first day will be the industry workshop at SCPR. Now, what is SCPR? SCPR is the Center of Professional Development and Internship here in in Lyon, which is actually where you will be following up this program. So there is a day-long workshop on 28th, which is the second day. Then on the 29th, the next day, the assignment is given to the students with your respective enterprises. Now, what are these enterprises? These enterprises are right from the big enterprise like Airbus, Safoni, which basically makes the Rafale engines, or the L'Oreal Paris, which many girls I know who is listening use. These are the big companies that we have tied up with, and these companies are using automation today to actually develop and market, and also give a wonderful service to their customers. So behind that is again coding and engineering at work to give a wonderful experience to the to their customers and to develop projects, products. So how they are doing it, we will be letting you know to discover in this internship. Now, various assignment, feedback, surveys, and related engagements on products and services chosen in and around city of Lyon, with offices and stores of our partners, companies, and all that, where you will be exposed to you. Then the last part of it is the report submission. At the end of this internship, you are supposed to submit a project which will be validated by the company and also the professors here of the partner institute, the institution, the university, and then you will be getting certificates. Now also, there are some visits arranged with the Chamber of Commerce. There is a guided visit to the this is the spelling mistake. This is a Rolex watches and the headquarters of Rolex watches in Geneva, and also the UN headquarters in Geneva, where all this pandemic has been regulated. So all those news that you see, it comes from there. So we will be also on the weekends, whenever you have free time, we'll be arranging those visits, and then there will be a certificate distribution, and most probably there will be a official from the Indian Embassy who will come to distribute those certificates, and at the end we have some a bit of a party, and then you fly back to India. So what are the partners? So some of the partners with whom we have worked, which are using engineering and robotics and coding as their base to give a wonderful experience to their clients, is L'Oréal Paris, Sodexo. So Sodexo is a French company, those of you who do not know and use it in restaurants. Then Cargill, the energy company. Renault, the car maker, the Duster is made by Renault. Carrefour, it's a very big chain. Auchan is also a big, very retail chain in India, just like Reliance Retail in India. It's there in Europe. Auchan, Carrefour, and Saint-Gobain. This is a company, like we talk about Google head and Twitter head being Indian. The CFO, and I met the CFO a few months back of the Saint-Gobain, is an Indian. Saint-Gobain is the glass that you see, the glass that you buy for your windows and all that. Then Rolex watches, of course. So we have this thing. If no, this is not for you because this is a keynote address. So I am through with my presentation. I welcome you guys in future to actually visit us and undertake this program, and I'll be very happy to actually welcome you guys and give you a wonderful experience. Thank you so much, Dr. Roshan and Dr. Deepak and Dr. Shilpi and all those who are involved, because I can't read all the names. Thank you so much for this opportunity to let your students know about the programs that we have, and also the importance of this new economy, which is very important for the Indians, and Indians are in good demand all over the world because of this new things. Thank you so much.
Thank you for your enlightening words, sir. It was a pleasure to listen to you. We feel privileged to have your supervision backing us. Your talk was particularly insightful at a time when students are considering new ideas to broaden their knowledge. I believe your words have set new levels of expectation that our students aspire for. On behalf of Amity University, Uttar Pradesh, I would like to extend my warm gratitude. We are highly grateful to you to have you with us, sir. Thank you so much, sir.
Thank you so much. Thank you.
Dr. Deepak God. Dr. Deepak God.
Yes, sir. Yes, sir. So yes, sir. So we are waiting for another guest, right, sir? So time is 3:10. So we have to wait for 5 more minutes.
Okay. No issue, sir. No issue.
Right.
I am waiting, sir. Yeah.
Good morning.
Good morning. Here, ma'am, now, right now, go post lunch, ma'am, right now. Good afternoon to all dignitaries, professors, and participants. Today, on behalf of Amity University, Uttar Pradesh, Department of Computer Science and Engineering, Amity School of Engineering and Technology, I feel privileged to extend my warm welcome to one and all for keynote address for Confluence 2022 12th International Conference on Cloud Computing, Data Science and Engineering. Today, I am happy to take the opportunity to invite our honorable speaker, Professor Dr. Silvia Liberata Ulo. Ma'am is a professor in the Department of Engineering in the University of Senio, Italy. Ma'am has contributed diligently in the field of the signal and data processing, satellite, remote sensing, machine learning, communications, networks, sensor networks, smart grids. Ma'am, we invite you on the platform to share a few words with us. Ma'am, you are most welcome.
Thank you very much, first of all, for your invitation. I'm very happy, really, every time that I can have some collaboration with Indian universities, I'm very honored and glad. I was in India in December 2019 and for 20 days. And I was very impressed for a lot of things, above all your courtesy. So I really hope to come back to India as soon as possible. And thank you for inviting me to take this lecture. Tell me, I have to go ahead with the presentation or...
Ma'am, yes, ma'am. Please go ahead with your presentations.
Yes, ma'am.
Okay, thank you very much. So I have to share first my screen. Please tell me if there are problems, if you don't hear my voice, if you don't see the slides. Okay.
Yes, ma'am, yes.
Thank you very much.
Yeah.
Perhaps I have to... Okay. The full screen, right?
Yes,
yeah,
ma'am.
Yes.
Okay, so this is the main slide of your conference. Very interesting. My congratulations to you for all the organizations, for everything. My small lecture, because talking about each of the topics in half an hour is quite a short time, but it's fine. So I will talk about remote sensing for Earth observation and cloud services. This is my name, my email for anybody who is interested in contacting me. Talking about remote sensing, we know that is a science that allows to obtain qualitative and quantitative information from an object, an area, or a phenomenon by analyzing data acquired from a remote device that is not in contact with the object, the area, or the phenomenon investigated. Satellite remote sensing, in particular, that is the part of the research I'm focusing. Satellite remote sensing allows the acquisition of data in the form of images over vast areas of the Earth's surface in a relatively short time. Remote sensing for Earth observation is a fascinating field of research, especially because it offers solutions to many problems of interest. In particular, the remote sensing techniques are applied to numerous fields, including geology, climatology, meteorology, oceanography, hydrology, but these are just a few examples, and that are based on the use of different sensors. Usually, they are divided in passive and active sensors. In particular, the active sensors transmit their own signals and measure the energy that is reflected or backscattered from the target material. And some examples are the LiDARs and the radars. Instead, the remote sensing using a passive sensor system, as we can see on the top of this slide, makes use, for instance, of the sun light, and the sensor, the passive sensor on board the satellite collects the reflected signals, or also the backscattered signals, and after that these data are transmitted to a ground station for processing and other operations on this data. Just a few slides, because I eliminated a lot of them because it's impossible, you know, to go inside some details. Most remotely sensed data are derived from the electromagnetic radiation, which include know that you know, there are two parameters that impact this electromagnetic radiation, and are the wavelength and the frequency, and they are both related through the speed of light. Anyway, this is an example of the passive remote sensing, of a passive remote sensing system, in which you can see how the sun lights a lot of different objects on the Earth's surface: buildings, roads, soil, the vegetation, water, and all the backscattered and reflected signal is then collected by the sensor on board the satellite. So we can say that the interaction of the electromagnetic waves after passing through the atmosphere, so there are many interactions with there are other aspects obviously skipped in this presentation. So the interaction of the electromagnetic waves with the targets, so the different Earth surfaces, the vegetation, the buildings, and so on, produces an answer that represents the spectral signature of the object illuminated by the electromagnetic waves, and contains the information on the physical and or the geometric characteristics of the target. So only after processing the satellite data is possible to retrieve this information. So data is one aspect, but the processing is another very important aspect. Otherwise, data are useless. Ground truthing is also an important part of remote sensing in general, because how do we know that the satellite data and the information is correct? Ground truthing is a way to validate the remote sensing data, because, for instance, we can measure some aspects of the soil, of the vegetation, of the surface, and then we compare these results with satellite data. We can perform an object recognition, and then we compare these results with the real objects on the ground. So ground truthing is a very important part of the remote sensing operation. Moving to the remotely sensed data, these are just some examples of images taken from different satellites. And I put these images on this slide because I like them so much. They look like paintings full of colors. So, and they can, they help to, to represent different aspects, different problems also of our planet. These are other examples. In particular, I put this image of India on the right. This is a satellite image taken by NASA in 2019. The sensor used in this case was a passive sensor, but since there are so many artificial lights, this sensor was able to capture this picture, this image, showing how the artificial lights during the night are well distributed over the India country. And this distribution of artificial lights is an important parameter used to show how how a country is developing. And in this case, we can see that the India country is developing quite well, and also in this period, if we take other pictures in 2020-21, we can see how this distribution has increased, showing an increase in the development of India. The advantages of remote sensing and satellite imageries are many, so these are just some of them. It provides a view of a large region of our planet, offers georeferenced information and digital information, land cover, land use, habitats, landscape, infrastructure, and most of the remote sensors operates in every season, every day, every time, and even in real tough weather. Other advantages are related to the multiple engagements by time series, and to mapping and monitoring the changes, and also to predict, in a certain sense, the future. This is more related to machine learning and artificial intelligence based techniques, but is also a research topic very important recently, in recent years. Just very quickly, when we talk about data, remote sensing data, there are 4 types of resolution that are important: spatial resolution, spectral resolution, radiometric, and temporal resolution. Spatial resolution is a measure of the smallest object that can be resolved by the sensor. The spectral resolution describes the number and width of spectral bands in a sensor system. The temporal resolution is the revisit time, is the repeat cycle of frequency with which the satellite and the sensor on board the satellite can revisit the same part of the Earth's surface. And the radiometric resolution refers to the number of different output numbers in each band of data, and is determined by the number of bits into which the recorded radiation is divided. These are just some examples of images here to show different examples of images for different spatial resolutions. You can see how diverse are these images for resolution of for spatial resolution of 1 meter, 10 meter, 30 meter, and these are examples of images for different radiometric resolutions, from 8 bits to 4 to 2 until 1 bit. Obviously, a lot of details gets lost. So this spatial resolution and these radiometric resolutions are very important, but together with them also the other 2 resolutions. All of this just to say, before moving ahead, that a lot of different images, different satellite data are collected with different characteristics. And it depends on the application. We have to choose the right sensor, the right satellite. In this slide, there are examples also of other platforms, not just satellites, but also airplanes, drones. What is important is the position of these different platforms and the distance with respect to the surface, the Earth's surface, because obviously this distance impacts on the resolutions that we were explaining before. There are many applications of remote sensing data in many fields of the engineering: civil, energy, computer science, environmental and electronic engineering, for land monitoring, observations and assessment and use, for monitoring climate changes, deforestation, pollution, atmosphere, agriculture, disaster risk reduction, and so on. Here there are other slides with many other examples of application of remote sensing. For instance, in this case, for urbanization and transportation, urban planning, for the roads, network and transportation planning, for monitoring the expansion of a city, for monitoring the city boundaries by time, wetland delineation, and so on. And in this other slide, we see another example related to agriculture, in particular including soil sensing, farm classification, farm condition assessment, agriculture estimation, mapping of farm and agriculture land characteristics, and so on. Here are application of remote sensing to natural resource management, in particular to the deforestation. Unfortunately, you can see on the right how from 1973 to 1986, how deforestation happened because this main road expanded, and so the vegetation was destroyed. In this other slide is more evident because there is a comparison of an aerial photograph on the bottom with a radar image on the top, and there is a clear deforestation along the main road. The Earth observation is done through satellite data that can be they are available, but usually a researcher has to pay for them. But I want to talk a little bit on the European Space Agency Earth observation system, because first of all, ESA has almost 50 years of history of remote sensing through satellite, from 1977 with the Meteosat 1 until now, with 25 satellites under development, 14 in operation, and many other satellites that have finished to work, unfortunately, because after 12 years, about 12 years, a satellite ends to function. The Copernicus mission of ESA is one of the most important missions, and I like to talk about this mission since I'm the first passionate about this mission. In fact, the policy that ESA has adopted was to make this Sentinel data data from the satellites that are called Sentinel, available free, full, open, over very long term, systematically and operationally. So since all this data and the tools have been made available for free, this policy has pushed a lot of researchers to use this data to make their study on Earth observation, to understand our planet, to understand how to impact through our research on our planet. So this policy has represented a very important milestone, in the space mission history. In particular, these are all the Sentinels. These are the scheme of different Sentinel 1, 2, 3 that have been launched until now. And each Sentinel has different sensors on board. For instance, Sentinel-1 has a an active sensor on board, while Sentinel-2 has a passive sensor on board. Different sensors means different kinds of applications. These are the Sentinel status. The green means that they are operative, that because they have been launched and the data are available. And these are all the possible applications from land cover typology. I try to go a little bit fast here. Agriculture land use, monitoring rice yields, the landslide monitoring, for instance. This is California, but this can be done in a lot of other places in the world through SAR data. These are the monitoring of and the measurement of displacements after an earthquake event. This occurred in Italy in 2016. This is an example of plant growth in spring during the 2017 year all over the world. So a specific parameter, that is the vegetation index, is represented in this slide. Here, the Earth surface heat is represented, and the color bar on the right represents the hottest and the coldest parts of the world in 2016. Here there are other examples: water level changes, volcanic eruption, wildfire monitoring. What is important, as I said before, is that this particular mission and the European Space Agency mission has made all this data available for free, but also the tools are available and they are online. So the Copernicus mission has made available a lot of data, a lot of online resources, the so-called cloud resources, and this is is very important. In particular, this is the Sentinel online, the official website where a lot of information can be found besides the user guidelines, but also there is the data access website. Here is the scientific hub where all the data can be downloaded. In particular, this is the SNAP platform, the Sentinel application platform. That is an architecture for all the Sentinel toolbox. Is called SNAP and is ideal for Earth observation processing and analysis due to a lot of important characteristics like extensibility, portability, and so on. Copernicus Open Access Hub, here there are also the link to these websites, looks like this. So you have to register and then you have to select a specific area, you have to set some parameters like this, for instance, the mission, the type of satellite, the period of interest, with the starting and ending date, the type of product, the acquisition mode. You select a specific area of interest. Here it was just an example. In the middle there is Benevento, my city. And then when you have pushed the search button, a list of available data appears on the left, and you can select the specific acquisition that can fit better your case study, your application. Besides that, Copernicus offers also data and information access services that are called DIAS that allow users to discover, use, process, and download Copernicus data and information. And all these DIS platforms allow access to Copernicus Sentinel satellite data, all information on products of Copernicus 6 operating services and cloud tools, open source, and just a few of them paid based on actual use. Traditionally, for the university, all everything is available for free. Besides this, there are some other cloud services made available. For instance, this is the Alaska Satellite Facility. It's very similar to the website of, created by ESA, by the European Space Agency. Also in this case, you can select an area of interest, and then you can get access to the data. You have to set some parameters. You push the research button, and then you can find the list of possible acquisitions, and you select the one more suitable for you. Another important tool is related to the Google Earth Engine code editor that was made by Google. Google, has become amazing, in the last years, because has made a lot of things, and also has designed solutions for satellite data processing. In particular, Google Earth Engine combines a multi-petabyte catalog of satellite images and geospatial datasets with the planetary scale analysis capabilities, and makes it available for scientists, researchers, and developers to detect changes, map trends, and quantify differences on Earth's surface. So satellite images plus the algorithms bring to real-world applications. Also in this case, the Google Earth Engine offers a dashboard in which is possible to make a lot of different things. Usually a little bit of Python or JavaScript knowledge is necessary, but really a few things. And these are examples of the components of Google Earth Engine. For instance, scripts, docs, so the documentation that you can see here on the left of the dashboard. And the editor allows also to write or to run JavaScript-based code. These are the other screenshot of the console and the task to download the data, for instance. These are examples to download the Sentinel-1 and Sentinel-2 data. And this code has been also made available by one of my PhD students. So I put the link of his GitHub account if someone wants to, to use them to practice a little bit with Google Earth Engine. This is the final image. This is the optical image. These are other examples of data processing. This is for min-max normalization, that is an operation often required for this type of data. This is another example of how to zoom on a particular of interest. Here there is the soccer game stadium in Benevento. And this is the final result of the stadium after zooming. I put at the end some references for interested people. Here are also a lot of works I did on these topics with colleagues and PhD students. The related academic journals are these ones. And I thank you for your interest, and I hope that the very quick and short presentation was clear.
Thank you for your enlightening words, ma'am. It was a pleasure to listen to you. We feel privileged to have your supervision backing us. Your talk was particularly insightful at a time when students are considering new ideas to broaden their knowledge. I believe your words have set new levels of expectation that our...
Thank you very much. I repeat, thank you for your invitation. Really, and I mean, I hope, and also in whoever is interested for collaboration, we have a lot of PhD students from India. We had a wonderful Diwali party some months ago, a couple of months ago. So we have students from your country, for a lot of other countries in the world, for master programs or PhD programs. So welcome whenever you want.
Yes, ma'am. On behalf of MIT University, Uttar Pradesh, I would like to extend my warm gratitude. We are highly grateful to have you with us, ma'am. Thank you so much, ma'am.
You're very welcome. Push the the end button here. Go out to finish.
Yes, ma'am. Yes, ma'am.
Okay, thank you.
Yes,
Bye. Ciao.
Yeah, ma'am. Thank you so much, ma'am. Thank you. Thank you so much, ma'am. Thank you. Thank you. Sayyid Akhtar Hussain, sir. Good afternoon.
Very good afternoon. I was very happy. How are you?
Yes, sir. Fine, sir. Fine, sir.
Talk with some of my students are sitting here. They've
Sir,
also
yes.
enjoyed my great METN. I'm also a METN. I'm an honorary professor of this fantastic university, beautiful
Yes.
university.
Yes, sir. Yes.
Proud that I had a chance to meet you and see you. Such a smiling face. All METN smiles like you. Thank you.
Yes, sir. Yes. Thank you, sir. Thank you. Good afternoon to all the dignitaries, professors, participants present today on behalf of MIT University Uttar Pradesh, Department of Computer Science and Engineering, MIT School of Engineering and Technology. I feel privileged to extend my warm welcome to one and all for keynote address for Confluence 2022 12th International Conference on the Cloud Computing, Data Science and Engineering. Today, I am happy to take the opportunity to invite our honorable speaker, Professor Dr. Syed Akhtar Hussain. Sir is a professor and dean in Canadian University of Bangladesh. Sir has contributed diligently in the field of natural language processing, artificial intelligence, speech and image processing, and in blockchain domain. Sir has contributed a lot in these fields with his technical acumen and distinguished work. Sir, we invite you on the platform to share a few words with us. You are most welcome, sir.
Thank you so much, and a very good afternoon. I'm going for sharing the screen, and I take you to my presentation. And I hope this presentation is visible.
Yes, sir. Yes, sir.
Yeah, visible. Thank you so much, and very, very good afternoon. My very distinguished session chair and the respected, audience. Good afternoon, and very warm greetings from the Canadian University of Bangladesh. It's a fantastic conference, and especially cloud computing, data science. These are all actually emerging technologies. Cybersecurity research is another very important area where I will be actually taking you into some of the thought-provoking, discussions. Do I have about 30 minutes time to elaborate on the understanding? Yes.
Yes, sir. Yes,
Thank
sir.
you so much. And
yes, sir. Excuse me, sir. Syed, sir.
Yes.
Please change in full presentation mode, sir.
Oh, you don't see full presentation mode?
Full presentation mode, sir. PPT presentation.
Yeah, but you don't see that, right? Do you see the full screen?
Yeah. Okay, sir. Okay. Thank you, sir.
Yeah, thank you so much. I want to start my presentation with a fantastic proverb, because what happens when it comes to cybersecurity, we basically have 5 natural defenders. We name it that these natural defenders that we have is practically few things like we have start with anticipation. What happens is these are all human attributes, but that is never ever based on any technology, and it is a constant. It is a natural defending. The most efficient cyber defender tool. One is anticipation. That means as a human, we can anticipate something is going to happen because we have that education. And then once we are able to understand that something is going to happen, we can detect and we have a reaction based on certain thing happens. And resilience is not, last but not the least, is the most important factor that helps us to fight back this cybersecurity. So cybersecurity is much more than an IT topic. What Stephen Napo, the former FBI director, rightly quoted. With this, I want to take you to my discussion outline. My plan is to talk about a little bit about cybersecurity. First of all, I will be actually heading here and then give you some perception of artificial intelligence, some roles of cybersecurity, especially in AI in cybersecurity. Cybersecurity research is a very growing trend. I want to address some point and then talk about certain directions in cybersecurity research with prospects and challenge and some references. But let me take you to the first discussion of the perspective. As you understand, when we talk about cybersecurity, we basically talk about a certain set of principles and practices, what you see here. And that is basically the purpose is to safeguard our network, safeguard our applications, safeguard our data. So what happens as a result, cybersecurity comes up with a technique to protect your computer, network, programs, data, and it's basically an unauthorized access. So cybersecurity today is known as an everyday living phenomenon. So as a result, what happens is that since the data is growing at a very outstanding rate, data is in a phenomenal growth, and so do the technologies. So cybersecurity is also evolving. And we need to understand that why cybersecurity research today is one of the very important area for all young researchers, and especially when we are going entirely digital, we have to protect ourselves from these unprecedented attacks, from this unseen enemy. We really need good knowledge to battle. And that's why cybersecurity research come into play and play a very important role. Let me take you that what are the security aspects it covers. We talk about application security, information security, disaster recovery, network security, and the last security that actually I have added myself, that business process today is completely automated. But imagine this business process security is a very vital part of every organization. And today you understand, the more you become digital, the more you are riding the tiger. And if you are on the tiger, you're going at the speed of tiger. But imagine if you fell down from tiger, you are inside the tiger. So my friend, I will actually ask all of you to see and think like this, that when we are becoming digital, we have the advantage of speed. We have the advantage of high-end productivity. But on the other hand, we are always at the vulnerability. My network is down, my data is stolen, my application is somehow penetrated by hackers, and I'm out of business. That is the bottom line. So with this, I'll take you to some aspects of discussions very quickly. When we talk about cybersecurity objectives, there are three things comes into play. One is we call availability. That means something is available all the time. Integrity, no one can change your data. You have a web portal. Suddenly one fine morning, you wake up and you see that your web portal is not showing your data, somebody else's data are shown. So integrity is a very important, and confidentiality. Why? Because your privacy should not be broken by any unexpected incident or unexpected guest. So talking from here, when we look at confidentiality, you have to protect your information. Common thing, what happens, the customers' username and password or the credit card informations, they are taken over the internet, and it's getting actually, hacked by many unwanted, guest who is visiting us. So that is actually where we try to have confidentiality as the first pillar. The second pillar we talk about is integrity. Why? Because no one can change my name against my ID and my personal information remains intact. Maybe you are in the Facebook, you are in the Twitter, you are in the LinkedIn, but you have to protect your personal information. So that's where it comes into integrity. And last but not the least is availability. Why? Because you are never disrupted. Your digital service is always on. But imagine pandemic today has gifted us with this wonderful opportunity, having conferences, and most of these platforms are highly robust and protected by all kinds of hacking, So let me take you from here, some aspects of research I want to talk about, some data. What happens if you look at the main issues that drive cybersecurity? It is unprecedented growth because you see, look at this reference. The reference is CompTIA. It talks about growing number of cyber attacks, and it talks about variety of attacks. Attacks are having different dimension. Why? Because of artificial intelligence, because of machine learning. Today, attacks are more intelligent than ever. They come and sit in your machine and wait for some time till that time comes, it triggers. So the attacks are actually more driven by AI. Your privacy is most important. That becomes more concerned. Your scale of attacks is dramatically changing. Resilience on the data. Why? Because my data, must be protected, and I must take care of my applications driven by this data. And then quantifying your security issues and breadth of skills needed, because this is where human resource comes in, and regulatory compliances. So what happens in the cybersecurity research area? You see, the cybersecurity practices that we have is still at infancy. Believe me, every organization, including my wonderful colleagues from Amity University, really have to see the kind of penetration testing that you can sustain. Identifying your own cybersecurity policy. Why? Because you have to safeguard your digital assets. And you see here, a couple of things what we have in place is zero trust. Then threat modeling is a very important concern. You have governance of the risk. You have workplace assessment and essentials. You have threat intelligence, which is very important, it's 41%. You see, among all this, there are three things are very important. Security monitoring, which is 49%. Then next is workforce assessment and education. Why? Because in our organizations, cybersecurity education is a mandatory education now. Why? Because you do not open any spam email. You may be taken away by hijacking your URL. So those kind of education. And third is the threat intelligence. So I will say that rather looking from that principles, as a whole, cybersecurity knowledge-based creation is just at beginning now. Believe me, many countries are attempting to create cyber army. So do Bangladesh. And we have a digital security agency. We work very closely, and we are continuously in engaging young talents to become cyber army for the country. So that's a very important aspect. Talking from these three aspects, that why we need to improve threat understanding. There are two aspects you can see here. Different types of attacks are here. Virus, spyware, phishing, firmware back hacking, IP spoofing, ransomware. You remember ransomware attack is very frequent in US. So do in our country. Many banks face this kind of attacks, but we hardly come to know that. You see, and on the other hand, if you look at the applications, IoT, social engineering, rootkits, SQL injection. So as a whole, the landscape of this cyber attack is growing because of technology, because of new kind of thinking, in terms of machine learning, artificial intelligence, and so on. So I will take you from here into the discussions very quickly because I don't want you to get bored by my discussions. But rather artificial intelligence, as you understand, that it's all about machine intelligence, but the intelligence is driven by data. You have a machine learning algorithms, and those algorithms are trying to predict something from the data. And once it predicts, that is a form of intelligence. We talk about artificial intelligence. And as you understand, the cyber crimes are actually driven by artificial intelligence today. Why? Because the malwares are intelligent malware. I'm going to talk about it. Those malwares, you can see here what happens in the perspective. You are developing different intelligent malwares, and those intelligent malwares having learning abilities. They come and sit in your machine and learn what you do every day. And one fine morning, all these informations are passed to someone who like to get information from you and in your absence. So yeah, is that okay? Any issue? Professor Roshan?
Yes, sir. Yes, sir. It's okay, sir. Okay.
Yeah, thank you so much. So what happens is that these criminals, the cyber, attackers, they are actually using AI practically to jeopardize your intelligence. But as I understand, we are in education for quite some time, and we understand that they are having a better education even than our own graduates, because they learn hacking from the very childhood, and they are into this kind of hacking for pretty long time. So talking from here, artificial intelligence actually is dramatically changing cyber attacks landscape. Why? Because the attacks are powered by AI. And if it is powered by AI, it is very difficult to differentiate from a cyber attack from certain known incidents. You may feel that my machine suddenly got a restart. It may be a natural event, but it is triggered by an intelligent malware to take your data and your information to another network where it is kind of a zombie. So it happens to be very interesting. So I will just be quickly going so that you are in a good learning speed. What happens is AI is transforming actually cybersecurity. As you understand that there are algorithms, there are data-driven applications, and I will be talking a little bit more about research. There are password protection issues. There are very common, like what happens, artificial intelligence and machine learning, phishing detection and prevention control is in practice now. Today, you see how many emails you receive in your inbox, which are phishing email. Very few, I will say very few, as compared to 6 years back, we used to have at least many individuals, they lost pounds and dollars. Why? Because of phishing email. I don't want to mention the detailed story, but today we see most of the email system are able to filter them out, so it's a better, living with phishing now. Use of, machine learning for vulnerability management. That's very important. And then automated network and system analysis. What happens, the scanning emails is very common, but as you know that it is already implemented into many practical email system of today. I will take you to here that AI absolutely relies on innovation like machine learning and other things, but cybersecurity and AI is a beautiful marriage. Why? Because cybersecurity is a kind of a situation you have to prevent, and artificial intelligence is your machine oil that actually drives it. So you have an engine and oil both together is a very powerful thing as a whole. So talking from here, I will talk about a little bit research. What happens is the cybersecurity research is a very challenging research. Why? Because it has to be driven by data. I'm just trying to make you a little bit, more out of my slides. So what happens, the data set? How do you get attack data? We call it attack vectors. In some cases, we found that you have to create your own attack vectors. How? You have a lab, you set up 3-4 machines who are infected, who has actually malware inside, that is in a separate network. Why? Because you cannot keep them in the same network. And what you do, you generate actually artificial attack data. You need attack vector to start your research. And honestly speaking, on the internet, you may find very little all these kinds of attack vectors data, because this attack vector data is used by, I'm talking about all antivirus companies, starts from I think the most important antivirus we started with McAfee to all antivirus, you name it. They have these attack vectors. So machine learning can be applied on the attack vectors to understand beforehand that some kind of attack is coming. And you can see the primary and the most fundamental challenge, as I understood, this is completely my own understanding I'm sharing, is generating meaningful attack vectors. You do not find this data on the internet. So security data collections based on real data incidents. I'm saying that you have data vectors, you have incident vectors, and you can connect that incident vector to a specific event is very challenging. You may get 1 petabytes or maybe 1 megabytes of data, but you have to know also what incident happened, what actually end result is. Why? Otherwise, how do you apply machine learning on this data? You have to classify them. So these are actually challenges, as I'm telling you, and also access challenge. Why? Because bank will never allow you to get their attack vectors. Why? Because this is all about their business. It is all about their standing and goodwill. So it is very delicate that you have these attack vectors. And observing attack pattern, as I'm saying, in time series, behavioral analysis, but these are very, very challenging. Why? Because you really need real world attack vectors based on certain incidents. So data aggregation, redundancy, these are all actually hypes connected to data collection strategy. And I will be showing you some effective methodology, how you can have cyber security research. So an effective cyber, these are my propositions. You can come up with an effective cyber security expert system model. What it does, you create a model for your cyber security expert system based on certain malicious data. And that model may lead to, that model can learn and grow. So what happens? You have a model, trial and error, you can come up with a successful model, and you can really sell this model at a very high price, as I'm telling you. So second thing, what you can do, a lightweight rule-based inference engine. What it will do, it will actually fit your data and find the incident. For what incident is attack vector? We need some kind of machine classification for the data generation. And a deeper understanding and designing an effective rule-based system, which is driven by AI, is a challenge. So my last proposition is that design and build an effective cybersecurity framework. We are still working for our country, but I will say every country, there is a team who are looking at it, and we need certain education to adopt this framework. So there are education component, there are development component, there are research component. All together, you come up with a effective cybersecurity framework in joint collaboration with industry and academia. That is badly needed. And I will just be very quick. I will show you that what happens in the landscape. You can see a picture which talks about the different aspects from data conditioning. Then you are applying algorithm. You have a machine, human machine teaming, and ultimately come up with a pattern. So this is an example I'm showing you that what is the attack pattern? Classic cybersecurity attacks mainly steal data, fine. What types of data? You're looking at 4 types of attack. Data poisoning is a very important kind of attack today. What happens? Some of the data are pushed in your system, which are actually dirty data. And this is called data poisoning. Tempering of categorization model, backdoors, and reverse engineering. I'll be very quick. I'll show you some interesting picture here. This is actually for about data poisoning. Attackers may bring carefully crafted flawed data into the legitimate data set. So your data set is not able to separate those data which are actually fabricated, which is not actual. It is very difficult. Like you see, it has been shown by adding 8% of erroneous data, AI system for drug doses, attackers could generate 75% change in the dose. Imagine if you are using a cancer drug, there are drug monitoring system for cancer patients. And if it is driven by data, and if somehow the data is poisoned, many cancer patients will die instantly because of just data. One simple reason. Some of the conferences which is happening around the world completely for cybersecurity, dedicated to cybersecurity and information security research. And I will be very quick here, directions. These are my directions. I'll be very brief here. AI and machine learning, absolutely. Assisted intelligence, there are 3 intelligence. Assisted intelligence, augmented, autonomous. What we are looking at is autonomous intelligence today, and ultimate future will be autonomous intelligence. A machine will learn everything and perform your office at the absence of yourself in the office. In the future, we'll have our laptops trained by my nature, and the laptop will perform my duties in my absence. That's what we are actually looking at as an autonomous intelligence. And these are actually some of the things which is very important. IT asset inventory, threat exposure, control effectiveness, which is very important, breach risk prediction, and incident response. As I'm saying, the last one is very, very important. In our country also, we have incident response. We have a CERT. We generally call it critical information infrastructure response team, incident response team, CERT. But what happens? People are not, they are not complaining. They are not, they are not reporting. So if they are not reporting, how do you know what happened? How can we have something automated which can help us to know the incident without any human intervention? And finally, I'm just talking about some cyber defense applications. I'm not elaborating this. This is an example from MIT. Typical research questions and goals for cybersecurity research. What cyber vectors? As I'm saying, cyber attack vectors is the foundation to start cybersecurity research. We need a database. We must have a clear understanding of for what incident is attack vectors. We must be able to create some risk assessment and mitigation plan, and kind of a process flow we have. You have a cyber attack catalog, the data, visualize, data analysis, and then risk priority and mitigation plan. So the methodology happens to be you collect data from critical infrastructure, you have a entry attacks, you have a main attacks, date of incidents, and then you do kind of a data analysis, find out what infrastructure is going to be infected, and then type of frequent entry attacks, most frequent attacks, come up with a dashboard for visualization. I'm showing a practical example of how you do cybersecurity research. And finally, the prospects and challenge, tremendous, because the coming time will live with, actually, I don't know, cybersecurity will never end. Why? Because security will be always a threat because of human, and we will continuously, infinitely do cybersecurity research. We need to develop information sharing protocol, as I'm saying, solve challenge for adequate enforcing their personal data, capacity building. Why? Because we do not have very well-educated cyber defenders. And finally, these are the challenges world is continuously witnessing. You are continuously facing, you do not know when we'll be under attack. And we need a good knowledge and awareness on AI. We must have a good training on AI. With this, I will have some references, and I'm very happy that these are something is continuously happening. hacked Facebook profile, e-cards, ransomware, and it's continuously going on. So I appreciate your patience hearing. Thank you so much. I will finish my presentation with a quotation from Christopher Ward. As cyber threats evolve, we need to evolve as well. So we need a continuous growth of knowledge and skills to fight back. Thank you so much for your patience here.
Thank you for your enlightening words, sir. It was a pleasure to listen to you. We feel privileged to have your supervision backing us. Your talk was particularly insightful at a time when students are considering new ideas to broaden their knowledge. I believe your words have set new levels of expectation that our students aspire for. On behalf of MIT University, Uttar Pradesh, I would like to extend my warm gratitude. We are highly grateful to have you with us, sir. Thank you so much, sir.
And I wish you a grand success. Have a very good day and have good stay, safe stay, healthy stay, long live. Thank you so much. And I'm taking a leave now. Bye-bye. Have a good day. Bye-bye.
Thank you, sir.
Good evening, sir.
Good evening, ma'am. How are you?
I'm good, sir. Sir, if you permit, we can start your session.
Yes, ma'am, we can start.
Sir, can I introduce you to the audience first?
Yeah, sure, ma'am. No problem.
Okay. Good evening to all of you, all professor, participants, and dignitaries and students present here. On behalf of MIT University, Department of Computer Science and Engineering, I feel privileged to extend my warm welcome to Dr. Anand Nair. He received PhD in Computer Science from Desh Bhagat University in area of wireless sensor networks and swarm intelligence. He is currently working in graduate school, Rio Tan University, Vietnam. He is a certified professional with 75 plus professional certificates from Cisco, Microsoft, Oracle, Google, GAQM, CyberRoam, and many more. Published more than 350 research papers in various national and international conferences, journals, indexed in Scopus, SCI, and ESCI with very high impact factor. He is more than members of a total 50 plus association as senior and life member, acting as ACM distinguished speaker. He authored and co-authored various edited books, 25 plus, related to computer science and other areas. He is associated with 500 international conferences as program committee, chair, advisory board, review board member. He has 5 Australian patents to his credit in wireless communication and AI. He is currently working in wireless sensor network, managed swarm intelligence, cloud computing, deep learning, machine learning, and blockchain. I welcome you, sir. And he is also got awards for teaching and research like Young Scientist Award, Best Scientist, Young Researcher Award, Outstanding Researcher Award, Excellence in Teaching, and many more. I welcome you, sir, and very happy and I'm very thankful that you accepted the invite, and I request you to kindly proceed to your talk.
Madam, but I can see there are only 7 participants. Do you want me to wait for 5 minutes and we can have more participants?
Yes, sir, sure. Yes, sir.
We can wait for 5. You can announce that we can start the session. So please, if you can.
Yes, sir. Yes, sir. Give me a second, sir. Sir, our students are joining through virtual platforms. Give me 5 minutes so that they can join.
Sure, ma'am. Take your time.
Okay. Sir, we can only see the panelist and students are already watching as a participant and attendees to various platforms.
Okay, ma'am. Thank you. We can start the session now.
Yes, sir. Please.
Good afternoon, ladies and gentlemen. I'm Dr. Anand Nair, and I'm working as Professor, Scientist, Vice Chairman of Research and Director for IoT and Intelligent Systems Lab in School of Computer Science, Dutan University, Da Nang, Vietnam. First of all, it's my real honor that I'm acting as keynote speaker for CONFLUENCE. And let me tell you, ladies and gentlemen, that this conference is very close to my heart because my first international paper was published in CONFLUENCE in about 7 to 10 years back. And since then, I'm regular publisher for this conference. So today, as we know that mobile communications is changing, and we are talking of 4G, 5G, 5G+. We are talking of Internet of Everything, smart cities, smart buildings, and of course, the flying cars and Internet of Vehicles. But have you ever imagined if you talk of such much of high-speed connectivity, we are talking of actually a high-speed communications. Now, in that type of communications, we are not talking of simple 4G or 5G. Imagine that. The world needs something else. So, ladies and gentlemen, today I will be giving you a detailed lecture that what is meant by exactly known as 6G into the world of computer science. So I have divided my lecture into 3 parts. So the first part will be in front of you. That will be 6G and why we need a 6G. The bit obvious answer, because you can all see that today we talk of massive connectivity of Internet of Everything. We talk of flying cars. We talk of Industry 5.0, cyber physical systems, smart cities, and of course, human society version 5.0. And that carries lots of requirement and connectivity problems that is actually can already be sophisticatedly solved with the help of 6G. And as we all know, 6G requires new spectrum. It's a cell-less network, high-end energy efficiency, and of course, it will be backed by artificial intelligence. So why was 5G defined, everybody? We all know that we are talking of space communication networks. Of course, we know about the Elon Musk. And Elon Musk has recently deployed Metaverse. And of course, we are also talking of the most important network that is called Starlink. We are talking of GPS communication systems, drones. We are talking of autonomous vehicles, hologram technology, augmented and mixed reality. And of course, with the power of blended learning, we are taking the virtual reality and extended reality to mixed learning. And of course, we need just one app to connect the entire smart factory where no workers will be there, but only robotics can communicate with the machines and machines will be giving you the data that what is the production process. So for that, we need to back up 5G, but the demand of new applications is actually improving like anything. So, but not everyone agrees with 5G. And as we all know that 5G has a still problem, we all know some problems with regard to radiations, but not that much. And of course, we need to deploy more antennas as we can thought of 4G. And you can say that still 5G has its own issues. Sometimes we all know that even if you are having massive connectivity with 5G, but the performance and the quality of service is not that much. I'm working over here from last 5 years, and Da Nang is a smart city, and we are having 5G towers here. But believe me, sometimes 5G is totally best, but sometimes 5G needs to be tuned extraordinary so that we can perform with better services and massive scale of operations. So 6G, as you can see that 6G is not right now in practical things. 6G is right now into alpha stage, which means it is just proposed. What I'm going to say you is just a proposed version. Don't think that what I'm going to say right now in 2022, it is going to be the exact that will be coming in 2028. It is still 6 years ahead of us. And still what is being researched out and what Nokia, Huawei, AT&T, Samsung that are all proposing is it in front of you. But don't think that it is final. Maybe it could not be that much, but maybe it could be better than that. So the time will tell you. So the capacity of 6G will be 1,000 times as compared to 5G, and the data rates will be moving from 10 Gbps to 100 Gbps. But we can still expect that if we talk of the forecasting future of more than 15 years ahead, we can even talk of the communication network with 1 terabytes per second. but that is going to happen one day, and latency will be reduced to 0.1 milliseconds, which means all the problems with regard to throughput, delay, latency, the buffering problem, it will be gone. Reliability will be 1,000 times better as compared to 4G and 5G. We will have less than 50 centimeter of indoor positioning, which means the accuracy will be 100%. The sensor and battery life, which is the biggest problem. And we all know that today, if you talk of your smartphones, your iPhones, the problem is not your display. When you on your 4G or 5G, they consume the battery like anything. And that's the reason that the most important problem will be energy efficiency, which will be actually removed with 6G. And of course, we have the connection density of more than 10 meters per kilometer square. So 6G will be having the possible technological disruptions that you can see that the spectrum will be improving from, you can say, 100 gigahertz to 3 terahertz. And of course, we are talking of laser line of sight communication, radio sensing and imaging, energy-free devices. And of course, there will be meta services to control propagation. We are talking of advanced communications, everybody, in which artificial intelligence will be improving all the components. But the most important applications that you can see of 6G is the most important is that I can buffer. You can see that if you talk of Netflix today, and if you're into a premium user, you are using 4K videos. 4K is good, but if you are in a bus, if you're in a railway, we all know it will not be able to stream even 320p. But in 6G, you can able to stream more than 8K of videos. Advanced industrial and robotic applications with cyber physical systems, communication for AI that will be in cloud, edge, and devices. Please mute yourself. Communication of all the 5 senses, and of course, augmented reality. So 6G performance, as I've already told you, it will be better in terms. Madam, can you please mute the participants, please? I'm getting disturbed.
Yes, sir. Sorry for the interruption. I'm talking.
Oh, please, please make it sure that I'm not getting. Madam, please make it sure that I should not be disturbed.
Yes, sir.
It breaks my continuity, please. Thank you so much.
Yes, sir.
The capacity, the data rates, of course, the latency, reliability, accuracy, the battery life, and of course, connection density. So whatever you can imagine, everybody, of today's communication problems will be all solved with 6G. But still there is a big question, what will be the environmental and societal impacts? Now, as a scientist, I'm saying you, I always foresee the future. Because we always design the future, we always work on our future patents, we are always working on futuristic technology. What I observe is that society, if you really want to talk of automated society, that connected society, that is around society 7. A hyper imagining thing that 6G will be improving our lives. But if you talk of environmental problems, maybe it will be 50-50. Maybe it will have more radiations. Maybe the radiation problem will be gone. So still it is into the alpha stage, which is into the stage of development. So let me tell you that we are not sure that what will be the environmental expectations from 6G. So 6G needs to consider the societal benefits and of course the word in 2035. So I'm not talking of technology of 2027 or 2028. It will still, I will be showing you the chart in my second presentation. So you will be stunned that still the development stage is still into very early stages of production. So a technology intensive global world, and that is called hyperconnect. Coffee with your friends, you take a selfie and you put it on Instagram or Facebook. It's common, but imagine if more users in the future come. Imagine that even today, even not 50% of the total population in the whole world is communicated is using internet. Now imagine if I increase that population to 80%, how much massive data we can generate, how much? And if suppose by 2032, I connect the whole planet and whole of the world is getting internet and smartphones and the laptops in their hands, imagine the world can generate the data. And imagine how much data centers we require at the back end. So for that type of thing, 6G is regarded as a lifeline for that. And secondly, a word of netizens and community sharing the commons. And we will see the world under heavy stress of data, nationwide political and economic declines, and unreliable supply of essential resources. So this all problems need to be solved with 6G. So resulting 2035 society and stakes for any word, the most important thing which I've already told you, environmental responsibility, inclusion and access to technology, sustainable energy production, resilience to massive and successive crises, affordable healthcare, data security, of course, privacy, and efficient industries and agriculture. Ladies and gentlemen, let me tell you very important. I'm working in IoT from last 6 years. And I have seen lots of projects that have been done on IoT based on cyber physical systems, industry, and agriculture. But in the near future, I would like to tell you that maybe in the agriculture farms, there will be no farmers. Like if you see of Amazon's marketplaces where there is no person working in those shopping malls, everything is automated. So I'm even working on a technology that how we can keep the farmers away, let AI, let robotics and drones, and of course, artificial sensors. Let's take the control over the agriculture farm and let's see how these machines can perform in the agriculture yield. And believe me, till date, the results are very encouraging. So energy consumption needs, and that is what we can see, that we need to efficiently have energy efficiency, and that is what leading to capacity gain. And of course, we are working on QoS, and I'm working on 5G into MIMO issues as well as quality of services. So the most important thing is with Wi-Fi 6, because our university is the first university in Vietnam that is adopting Wi-Fi 6 in the new building. So with Wi-Fi 6, we can imagine that the capacity of laptop batteries and even our mobile phones will be even better. So Wi-Fi 6 and the other techniques will be better to adopt in the near future. So environmental benefits. So still, I'm not confident that what is going to happen, but still I would like to give you some idea that maybe what will be the quantification towards energy consumption and CO2 effect. We are still not sure. And we have to develop sustainable services, equipments, including the terminals. And of course, the ecosystem will involve devices and service providers. And you can see from this diagram, everybody, we can see from equipment to recycling. And we are actually working into this infrastructure, which is backend by Orange Networks, which you can see it is about 3.8 TWh, which is actually better. So this type of network will be able to provide a strong backhaul for Internet of Vehicles, autonomous vehicles, and high-speed connectivity. And this is the most important area where we are working, because today as a professor of cybersecurity, I'm teaching cybersecurity from last 10 years, even I'm a professional hacker. So today, even when I start my class for information security, like information warfare, I always tell my students security is not a problem because we have AI, we have advanced idea systems, we have deep learning there, but the problem is the privacy. And 6G is the only answer, because now we are doing our research that how we can mix up blockchain with 6G. And if we add blockchain, we are adding actually end-to-end security, which is not even possible for even quantum computer for next 10 years to get it breaked, which means we are with blockchain system, we can make the security and privacy a big solution, that there will be no ransomware attacks, man-in-middle attacks, and the data will be completely private. So digital inclusions, and that is what we want to see. And of course, we need to have digital inclusion in terms of societal concerns. We need to have low density areas at affordable cost, like LEO satellites and D2D networking, and access to technology for all. So don't think that in the rural areas, technology will not be there, but with 6G, it will be affordable. So networks need to become more EMF aware, and that is where we need to work out, but still it is under alpha testing, so we cannot promise you much. So with massive IoT with RF tags without additional waves, you can see how much EMF radiations can be there, but we still have to solve this. So everybody, this is called the system design. So the most important thing is societal requirements, in which we have the most important problem with regard to energy awareness, the awareness of EMF, digital inclusion, resilience, security, and of course, E2E, environmental impact should be completely low. So this would be the answer, and that will be the trade-offs for 6G. And of course, we have the flexibility and ease of operations, because NVIDIA is working, and NVIDIA is also working on green IoT and green data centers. And with that, we have the better design dimensions in cost-effective manner, and we allow the network operators to set the trade-offs. So how to set the design targets for 6G? The first important thing is consult with future users, that what do you exactly need? Now, imagine everybody, we have done a survey over here in Da Nang city, and we have taken more than 6,000 respondents, that what is the problem with your smartphones? They always say me, sir, we are doing mobile gaming of PUBG, or maybe we are playing World of Warcraft on our smartphones, and more we play, the less, and we sometimes find connectivity problems. Sometimes we need to have to stream some downloads. We want to play Netflix on 4K. We want to stream YouTube videos, everything. So they require lots of connectivity. And of course, I want to add many, many photos automatically on Facebook, which means the more interaction will be the online services. And you will be stunned to know, even AT&T has done a survey recently. You will be stunned to know that out of 10, maybe the calling feature was at the 9th number, which means people don't want to use the phones for the calling feature and even the messaging feature. They want to use, the first feature was social media, that if you are having a smartphone, why you want a smartphone? You want to use Facebook. And the second was uploading the photos. And the third was watching the videos on YouTube and Netflix. And I was stunned that it's a smartphone or it's a multimedia handheld device. So the requirements for the futuristic phones is actually massive. And that's the reason we need to have to curb the design latency, energy problems, and of course, environmental problems that can be solved with 6G. So the technical priorities from expected societal requirements, that would be the energy efficiency, network traffic streamlining, and of course, sustainable services, equipments, and terminals. Okay, so this will be my part number 1. Now I will be coming to part number 2 of my lecture, in which I will be discussing very important aspect, that will be 6G in the next frontier, vision, roadmap, and technologies. So everybody, 6G, the road to the global brain. Now, if you ask me today, which person has laid the foundation for today's mankind? No doubt there are lots of scientists, but according to me, the great scientist that actually blessed us what we are today is Nikola Tesla. If Nikola Tesla would have been not there, let me tell you today, you are not even, you will be away from your smart machines, your IoT, and of course, your electricity. He was such a great scientist, and he was such a low-rated scientist. So he has given a very important word if you really want to understand the futuristic of mobile communications. When wireless is perfectly applied, the whole earth will be converted into a huge brain. Now imagine Google takes your data, and I have already told you that 50% of world's population is not connected to the internet. Now, if 50% people are there, every person is not uploading the photos on Google Drive or maybe Google Photos, and everybody is not on Facebook. Okay, now imagine if they have so much of data that they're doing machine learning and they're improving your photos and they're applying better Pixel 6 cameras, and even iPhone 14, we can expect with 48 megapixel cameras with machine learning. Imagine if the whole earth is getting connected, how better we can see our machine learning and deep learning with better data sets. Now that's a question to think, that what will happen that if whole of the society is on the internet and they're connecting and the massive needs are getting to be solved. So by 2030, we can expect responding to fundamental human and social needs will be based on Tesla proficiency will becoming a reality. And of course, his vision for 2030 was defined about 100 years back, that what is going to happen. So 4G and 5G have started addressing such challenges, but we are just at the beginning. We are just at the beginning now, because even today, you all are listening to me from India, but still, according to me, 4G is not even the best quality of service. If you say 5G, 5G is still a joke, because India is a massive country. We need massive computing hardware and of course, antennas to scale that connectivity of 5G. So 6G will provide an ICT infrastructure that will be surrounded by a huge artificial intelligence. Now imagine if AI is actually involved with communications, how much we can deploy the machine learning and deep learning algorithms to make more new applications and realistic real-time solutions. And that is where we can say that if you're talking of best drones today, they are not using wireless technology, they're using the edge technology. So that will be offering zero latency services, unlimited storage, and immense cognition capabilities. And that is what we need to have. So 6G will not only collect the earth, but it will be having skyless boundaries, limitless. I'm saying you, even if we are talking of the pre-stages of research, we have seen such results that we even don't have that capacity of equipments and other, you can say, softwares that we can even test the benchmarks of 6G. We are not in that capacity right now. So sustainability issues for beyond 5G, and you can see the most important problem is 3.5 billion people are still without wireless internet. Still, Wi-Fi is still not available in some countries. Over here, if you come to Da Nang city, you will be getting bored of internet. Even when I go to cut my hair, when I go to just drink a coffee, anything, they just take your phone that say, sir, please use the internet till we come to you. So every whole, I can say every street, house is even connected with massive internet connectivity. So energy and sustainability in hyper-connected society, this is a big issue. And that is what we want to solve. And of course, security and autonomy, e-governance, and industry implementations. So what we need is a new generation. So if you talk of these issues, these are the issues that are actually connecting with 4G and 5G. And now we want to remove these issues. And that's the reason we need 6G. That is why we need a new G generation. So technological breakthrough. We need a breakthrough because if you talk of IoT today, people forget that, okay, sir, we add sensors, we add devices. Okay, good. But what about the connectivity? We are not talking of 100 sensors. If we are talking of agriculture farm, we are talking of more than 5,000 sensors. And even I'm happy to inform you that we have even discovered the new benchmark. Even I'm the inventor of LoRaWAN. We have done more than 6 LoRaWAN projects last year. And even today, we are also deploying LoRaWAN to 3 robots with 2 agriculture farms. And that is what we want to see, that massive number of sensors will be connected to one gateway, and one gateway will be connected to the internet to get the data from the sensors, and there will be bi-directional communication, which means two-way. I don't have to be on the field. I just take the sensor number and I can make it off. I can make it on. I can reconfigure it. I can do anything. And the distance coverage and the security coverage is, of course, remarkable. So we need new services, we need applications, and we need use cases. And in the future, everybody, the most important thing is the country that spends more towards wireless communication research will be the future leader of tomorrow. So in the future, I'm going to tell you that those countries that have a better healthcare services, and second, they have more connected services, they are the winners. They are the powerful countries of the world, most powerful. So why we need a new generation, which you can see from the applications, we are moving towards terahertz communications. We need LoRaWAN, we need brain-computer interface, and of course, the services in terms of mixed reality, gaming, and of course, we need the massive connectivity on healthcare and blockchain services. And that will only lead, and that can be the only answer that 6G can provide this massive requirement. So don't consider 5G, it will be 6G. So 5 sense technology interaction, and that is called hologram. So don't think that in the future you will only use Facebook, Oculus Rift, or maybe Google VR, or maybe like Google Glasses, or maybe like HoloLens 2. We are talking of hologram technology. And still it is under the pre-stages of development. Some companies I know, I have good connections with some companies like Facebook, and still they are working on hologram technology. And of course, the interaction will be the haptic communications, which will be actually moving towards computing, communication, caching, and control. And that will be the C4 system that can be only sophisticated with the terabytes per second. So this is the map, everybody. This you can please see at your own level. So you can see that if you talk of 6G, 6G components design will be starting from 2022 onwards. And that's the reason why I am starting the year with 6G, because 6G is going to be the center point of attraction of research from this year onwards. And of course, for the test beds, we still need 3-4 years to design. And of course, for full services that you can see right now, even it is pre-planned, but we can expect that, of course, by 2028, we can have that 6G. Still, iPhone 13 Pro and Pro Max have 5G antennas. 14 Pro is also coming by March. We are expecting the next Apple event in March, and we are expecting iPhone 14 Pro and Pro Max. And what we have absorbed is that we are going to get 48 megapixel camera, and of course with 5G plus and radio antenna. But if you're talking of 6G, maybe we can expect that iPhone 22 will be powered as the first product from Apple, which will be having 6G. So imagine that still we are not ready for this technology. So assumptions will be AI will be dominating the delivery area, the fruition area, and of course, the extended reality will be massive. And we all know, if you talk of today's digital twins, I don't know how many of you are working on digital twins, but digital twin is very, very important for you to understand. So digital twin is actually moving towards in the direction for industries. They are working towards to massive displays, holograms and other things. Believe me, digital twin is the future for everything. And we are working over here, and I'm doing one project with digital twins, how we can assist the dentals before they perform some maxillofacial surgery on a patient. They can use a 3D model of that face, and they can do that surgery on in a simulation model before they perform the surgery on a real-time patient. And that's what we are using HoloLens 2 along with the technology from Siemens. And that's a massive project that we are doing in-house in our university at CVS lab. So 6G requirements will be having infinite capacity, 3D intelligence coverage, zero latency networks, extreme power and energy-free connectivity. So everything, whatever you think of 5G problems today will be solved with 6G, but we need still 5 years more or 5 or 6 years more in order to experience that technology. Okay, but what will happen? What about the antenna position? What will be about the quality of service position? Unless or until we are not having the real-time product, we can't say that, because still Nokia, Huawei, Samsung, AT&T Labs, many other carriers like Orange, China Mobile, they are working together to make this possible, but still it is under the research in progress. So this is the massive difference between 5G and 6G. And you can see that 5G still, now ask yourself, are you getting any Gbps connection with 5G? No, because still you are not into best quality of service. But over in 6G, I'm talking of terabytes per second. Yes, everybody. And you can see uniform user experience will be 50 Mbps of 2D, but I'm talking of 10 Gbps of 3D anyway, everywhere. So this is the answer. And of course, the energy bit will be almost gone. So this is the 6G part to sub-terahertz spectrum, and this will be the frequency of interest for all of you, which you can see the D2D and enhanced hotspot and ultra high capacity backhauls. So this will be the more spectrum above 90 gigahertz. And you can imagine that the breakthrough of technology in terms of throughput and of course with massive scaling of users will be infinite. So I just come to this one. So this is about the beam forming approaches. You can see some of my research papers that I published last year, more around to 5G and wireless communications. So issues with high directive antennas with regard to blockages, mobility management, and beam alignment. That is the main problem with 5G. That's why we need to fit many antennas. Okay. And let me tell you about this one. So this is called Visible Light Communication Roadmap. And you can see that from 2020, we started with multiple users at 100 Mbps. And 2022, now we are not talking of any Mbps, we are talking of Gbps in terms of wireless connectivity. But by 2024, we can have spatial mux that will be leading to 20 Gbps, and wavelength mux will be coming by 2026 up to 100 Gbps. And that is what we need to have the maximum capacity when we are ready by 2027 with 1 terabytes per second. So we need to be ready with this type of visible light communication in the future. So from 2D centralized connectivity to 3D distributed intelligence, you can see that 6G networks integrate terrestrial and non-terrestrial components. And of course, we have the multi-link connectivity when everything will be having ultra reliable and low latency computation. And of course, the real-time computing and caching can be done because drones technology must be requiring this type of real-time caching. And we have the seamless C3 mobility and connectivity. So this is about the potential for meta materials that you can see, the growing interest for intelligence services, and of course with 6G localizations. And of course, I would like to tell you that before I wind up the lecture, the quest for more distributed intelligence will be in-memory computing, less data for traveling the time, new programming models, and of course, computational caching that you can see from demand and compute to search and download. So imagine everybody, this would be a new area for you to research that what exactly is in-memory computing and how you can achieve it and what type of new algorithms you can work and what kind of applications problem in today's world can be solved with in-memory computing. This is a very good area to research to understand wireless communications and to come up with the solutions for today's problems that can be solved in the future world. So the conclusions will be a new physical layer incorporating sub-terahertz bands and VLC will be there. Exploitation of RF-RIS services for both connectivity and localization, and distributed security mechanisms, innovative cryptographic techniques, and of course, we are also working on blockchain technology. So 6G will be the next frontier, and that is what we have to see, the road to global brain, the road to connected earth, and of course, the connected applied with applied intelligence. So this could be the end for this one. Okay. So increased efficiency of spatial bandwidth, that you can see the integration of satellite communications for enhancing the bandwidth. That's why the Starlink network is very important, but we can expect more types of networks coming from Orange and Huawei in the near future. So this will be the integrated terrestrial in 6G handoffs and roaming to form the big issues, and handovers will be the C3 architecture in terms of communication, computing, and caching. So this will be the graphs that you can see that I have adapted from 2 or 3 research papers. That is how the application of 5G channel modeling for 6G systems in terms of performance evaluation. So more bits, more spectrum, and of course, in terms of antenna embedded. So imagine if you really want to research on antennas, try to work with AI-oriented antenna beamforming. That's a very good area to perform the research. So this will be the societal stakes that you can see at the 2030 horizon: energy efficiency and environmental responsibility, efficient public services, and the most important thing that you can see on my line right now, others cannot be predicted right now. So the conclusions will be the edge eating the cloud. So the future is not cloud computing, the future is edge computing with efficient local data acquisition and joint C4 computing, communication, caching and control, intelligent memories and storage, and of course, in terms of ubiquitous 3D connectivity and intelligence support that we can see in UAVs, satellite, and of course, autonomous vehicles. And ultra high capacity sub-terahertz communication with visible light communication and non-cooperative schemes. So thanks a lot for inviting me, everybody. Now the house is open for all of you for 10 minutes. If there is any question, let me know.
Sir,
Any question, let me know.
Sir, they will be sharing questions through chat, if any, and thank you so much, sir, for your enlightening words. It was a very pleasure listening to you, giving the insights about this technology, and we feel very privileged to have your supervision backing us. Your talk was particularly insightful at a time when students are considering new ideas to broaden their knowledge on this research area. On behalf of Amity University, Uttar Pradesh, I would like to extend my warm gratitude to you. And again, thank you for accepting the invite and getting time for sharing your views on this technology. Thank you so much, sir. And I want to share that more than 200 students were listening to your talk.
Oh, thank you so much. So
Yes,
if
sir.
they have any problem, I just give my email to the chat box.
Yeah, sure, sir.
So if you want to email me, you are most welcome to write an email to me. And if you are on Instagram, you are most welcome to follow me. And here is my website. And if you want to do search on Google, you can just search my name. And for YouTube, this is my channel. So thank you so much, ma'am, for coordinating. And thank you again.
Sir.
And if you need me in the future for any webinars or faculty development programs, you are most welcome to contact me anytime.
Sure, sir. Sure, we will. Thank you so much, sir.
Sure. Thank you so much.
I want to welcome Dr. Basanta Joshi, Deputy Director, Center of Applied Research and Development. Sir.
Yes, ma'am.
Good evening, sir. How are you?
Yeah, I'm fine, ma'am. Thank you very much for allowing me for
yeah. Sir, I will give a brief introduction about you to the participants and the people listening to you. Then you can start your talk.
Okay.
Okay. Good evening to all of you, professors and participants here. On behalf of Amity University, Uttar Pradesh, Department of Computer Science and Engineering, Amity School of Engineering and Technology, I feel privileged to extend my warm welcome to Dr. Basanta Joshi, Deputy Director, Center for Applied Research and Development, Tribhuvan University, Nepal. He is currently Deputy Director of Center for Applied Research and Development. He has having more than 8+ experience as a professor in the field of electronics and computer engineering. He is interested in working for innovative, challenging, research-oriented projects and problems. He believes in sharing ideas and experiences by participating in discussion, presentations. Moreover, with his experience in academics and research, he guides students interested in research work and consultancy in IT industry and projects. I welcome you, sir, again. and request you to kindly proceed with the talk.
Thank you very much, ma'am. I'll share my screen. Is my screen visible, ma'am?
Yes, sir, it is visible.
Okay. Thank you. Thank you very much. So first of all, I would like to thank MIT University for inviting me for this speech in Confluence 2020 again. So I was invited a few years back also. So as ma'am mentioned, so I am working in Trivandrum University, and currently I'm working as assistant professor in Department of Electronics and Computer Engineering, and our institute is known as Institute of Engineering under Trivandrum University. So all my positions are under Institute of Engineering, and so especially I would like to point the fact that I'm currently working for Center for Applied Research and Development, and basically this department is actually focusing on enhancing the capabilities of our faculties and students by applying for collaborative bands, faculty exchange, and all other research activities. So yeah, so I would like to share this. So apart from that, I'm also working as a member in a laboratory for ICT research and development that is focused especially for ICT research. So talking about me, I have industry experience as a software engineer, and after that I moved to the consultancy work, and this work which I am presenting, this insider threat detection using deep learning, is one of the consultancy work associated with a LogPoint, a security company. So I was working there a few years back, and now most of my students from that company are working on identifying the insider threats. So this talk is related with that. And my research area is basically I'm working on, some of my students are working on image processing, video analytics, and also my students are working on natural Nepali language processing, and mostly all of them are related with application of machine learning in different areas. Okay, so talking about my today's presentation, so I will be briefly introduce the theme, and then I'll talk about SIEM, insider threat detection, UBEA, and I'll briefly show the results what we have obtained using some of the deep learning algorithms. Okay, so talking about threats. So, but threats can occur from external or internal sources. So whenever we talk about threat, then we might be, some of you might have been thinking about firewall, which is identifying different kinds of insiders, different kinds of threats. And also, so whenever we talk about threats, there are different kinds of network components installed, which is used to detect and stop different kinds of threats. It is identified that 68% of organization, there are insider threats happening, and also it is found that 78% they have no effective user privilege assignment. So most dangerous type of insider threat are the people who are working in the organization, and basically they might be regular employees, and they might be privileged users or administrators, and they might be third-party temporary workers who have access to the system. So talking about insiders threat that has happened, important insider threats like Microsoft database was leaked because of one of the employees' negligence in 2019. Also, Tesla's data leak happened by employee Martin Fripp in 2018. Also, there was data leak associated with Marriott company, and also General Electric employees stole trade secrets to gain the business advantage. And also there are a lot of other information that has been leaked associated with Twitter, Cisco, and also Amazon, Shopify strategies. So all these kind of companies, very renowned companies, they are having the trouble of insiders trade. That is basically the employees are leaking their trade secrets or their data. Okay, so actually, whenever we talk about insiders trade, statistically, it is found that it's very difficult to detect the insider trades in 49% cases, and also it's sometimes it's very difficult to predict the actual damage in 82% cases, and it was found that and also the threat monitoring is one of the very challenging tasks, and there have been different softwares that has been developed to monitor these kind of threats. So I will be basically talking about my talk will be focusing on security information and event management system. So SIEM system. So, and the application which I will be talking about is one of the application that is being currently done with one of the SIEM company. So whenever we talk about monitoring the system, so there are different kinds of system that is actually generating the log files. So that is considered as event logs. So if you talk about our operating system, so it is, if you talk about assessing the servers, if you talk about assessing the databases, so all these events have been recorded, and basically the logs have been created during assessing, deleting, adding file or modifying file, along with the system dates, and also the system assessing that particular devices. So all these informations have been created during those activities. So whenever we talk about these kind of events, different kinds of logs are being generated, as I mentioned before. So not only by the applications, but also there have been different network devices which are keeping the logs, so routers, switches, and also domain controllers, and also different kinds of applications. And also, as I mentioned, there are different kinds of servers which are actually tracking the events. So whenever we talk about monitoring the system, so in the different organizations, they have been monitoring the activities across the world. So they have been using, they have the special security operation centers, which has been working 24/7 to monitor the activities, actually basically security related activities around the globe. So whenever we talk about security, so if you go by dictionary standard definition, basically security is a state of being free from danger. So now the question is how to be free from the danger. So whenever we talk about freeing from the danger, we talk about firewall, antivirus, and different kinds of policy, regulations, all that has been actually identified to make our system secure. So so basically what we need to, as I mentioned before, so different kinds of insiders threats that has been associated with the companies. So we need to guarantee the privacy, we need to guarantee the trust and access to the system. So that particular system should provide these kind of things. So one of the system that is working on this area is actually SIEM. So it's basically combining security information management and security information management and security event management. So basically, this kind of system deals with real-time monitoring. And so whenever we talk about this kind of system, they actually not only monitor the system, but they actually correlate the events and identify the threat associated with those events. So, and based upon that, they have some kind of visualization module which shows those kind of correlation or association. Okay, so whenever we talk about this kind of system, they actually store those kind of events, and also they do the analysis of all those data that has been being collected. So whenever we talk about these SIEM systems, they actually work on log collection, log analysis, event correlation, log forensics, and log monitoring, and also real-time alerting. That is very important thing. So whenever any kind of security breach occurs, they actually alert the users about those kind of breaches. And also they use different kinds of dashboards and reporting tools to alert the users about the activities. So these are the features of SIEM. So whenever we talk about compare SIEM and log management systems, so basically both of these components actually collect the logs, they pre-process the log, retain the log, but mainly SIEM focuses on security based reporting, and they actually do the correlation and analysis related with events, and they prioritize some of the events. So that is very important. And most important thing is, like I mentioned before, they actually alert the users, they actually identify some incidents. That is very important. So all these things are being done by the SIEM. Okay, so whenever we talk about security challenges, then we need to talk about data exploitation, shared account, abnormal user activities, vulnerable systems, movement of data, and system infections. And whenever we talk about data challenges, then one of the important thing is the different devices are generating a lot of data. So the format of logs that is being generated is very different, and sometimes the log which are being generated is not in a proper structured format. So we have to process those unstructured data, and also the system which is collecting those data might be these days those devices, maybe that system, like let's say banks have branches in different remote locations, and all these activities of a branch has to be all those activities has to be collected, and so that might be stored in the local server or in the cloud. So that will be so all these logs will be collected and stored in a distributed environment. So that is another thing, so we have to take into consideration. And so also whenever we talk about logs, so we need to do parsing, and since it is coming in the let's say different devices are generating, and as in before presentation the sir was talking about 5G and 6G. So in that case he was talking about IoT and 10 Gbps throughput. So so whenever we talk about 10 Gbps, so definitely there will be a lot of data. So that's the future. But currently we are talking about 1 Gbps speed, and a lot of data are being that is arriving. So we need to use the tools that is associated with big data tools. So that is considered as, so that we need to manage, like use volume of data. We need to manage the logs that is arriving at the high speed. So definitely we have logs coming from different sources. So all these things we need to do, and we need to use the tools associated with the sophisticated system that is can handle the big data. So whenever we talk about SIM workflow, so as we mentioned, as I mentioned before, what we need to do is we need to collect the log from variety of sources. So, and then what we need to do is we need to as I mentioned, that logs can be collected in a distributed environment, and also the format of the log might be different. So we need to actually use collector for different kind of data sources from where we are collecting the data, and then we actually use to normalize the data. It means that we need to identify the important parameters from that particular data source. Like sometimes the important parameters may be IP address, one of the important source and destination IP address, and another important parameters might be activity, what we are doing, like if we are logging onto the system, if we are log out to the system, if we are transferring the file. All these parameters need to be identified, that can be identified through normalization. Okay, so after this normalization, so what we do is here we can see that here we can see that we can collect data from different sources, and we normalize the data, and sometimes we add additional fields to that particular logs based upon our requirement, and then we store the data. So the logs can be like this. So let's see. RAM log in successfully from source 192.168.2.10 to a workstation this. So, and another thing, maybe a log text remote logged in successful login David from web GUI at IP address this. So whenever we compare the first and last log, they are completely different, and there are different it's not properly structured. So we need to parse those data and identify the important parameters from these logs. And additionally, we are actually assigning the severity of that particular log also. So that is considered as enrichment. So whenever we talk about logs, so it's very difficult to actually normalize the log. So because those logs might be coming from different sources and the pattern is different. So what we need to do is we need to find appropriate techniques to cluster the logs and actually extract the relevant information from log. One of the approach is suggested in this paper, which was published in 2014. And so after the log is normalized, then we have the important parameters that is coming from the log. So after that, we can do the correlation and we can identify what are the associations with those parameters, and we can allot the particular users about those events. So we can do like that. So that means what we need to do is we need to correlate the events. Actually, we need to link the events to identify attacks. So we can use rule-based techniques like, let's say, if X repeated 3 times within an hour, then do Y. It means that, let's say, if the password unauthorized user is trying to type the password more than 3 times within an hour, then we allot the system administrator. We can do that like that. But that is the rule-based techniques. But whenever we talk about correlating the events, we need to identify not only based on the recent pattern, but also we need to identify the pattern of user from historical events. So then in that case, we need to find actually the anomalous users. That is the users that is the activity that is completely different from the activity which was being done in the past. So let's say one of the user regularly is assessing the system. So abruptly assessing the user system, and he normally opens the Word file, and he only does those kind of activities from the server. So today, what the user did was he tries to download a lot of files from the system. So in that case, what we need to do is we need to check whether that is, let's say, what kind of user is that. And based upon the historical pattern, we might say that that person is doing abnormal activity compared to his past events. So we need to allot the administrator about those kind of things. So administrator might be deciding whether that is low, medium, or high or critical type of events. So there might be some kind of rules which we can write identifying the severity also. So whenever we talk about security related events, then we need to talk about different kinds of compliance, and this kind of SIEM softwares, they have been generating different kinds of compliance reports regarding the standard compliance reports. So, and what we do is we actually store those logs and also the associations we recently identified into the database, and that can be used for forensic investigation. So this is one of the SIEM tool that has been developed by HP ArcSight, and they actually collect the logs from different sources, and actually they have been storing the data in the storage area network, and they have been using different kinds of systems that has been analyzing the data. So, and they have been generating different kinds of alert messages based upon the events that has been occurring. So whenever we talk about SIEM deployment, so what we need is we actually have, as I mentioned before, we might have different kinds of sources that is generating the logs. So we need to associate those devices with the collector, and that the collector might be on the premises in the same system where we are collecting the sources, or the collector might be in the cloud. So for both cases, what we need to do is we need to actually normalize the data, and we need to actually alert the client about the activities that has been happening in their premises or in the remote premises. So whenever we talk about application of SIEM, so what we do is we actually provide the companies that has been using SIEM application. That might be bank, that might be the company which has a variety of branches in the different regions. That might be post office, that might be university, that might be different kinds of companies which have the branches. So for all those users, that might be software company, that might be different kind of companies, as we mentioned earlier. So for all those companies, we actually generate a report and alert about important activities to the administrator. And also there should be some searching mechanisms, so that we can search what has happened in the history. So you might have heard a lot of a lot of the insiders activities that has been happening in share market or in the bank also. There might be some cases like, as you might know, that whenever we use a debit card and our credit card, there the sum of the for each credit card or debit card uses, bank is getting some commissions. And so some employee, what they can do, especially IT employee, what they can do is they can transfer the amount that was little bit percentage, like 0.03 or 0.02 percentage, to their account instead of transferring to that bank account. So that kind of activity, it's very difficult to monitor. So for that to be identified, we need to do some forensic analysis. We need to do some forensic analysis. So searching is very important thing for those kind of activities, because we might not have faced those kind of security breaches before. So for that, so we need searching facility in the future, so that we can identify those kind of security breaches also. And also the SIEM application actually it can create the summary of the events, summary of the activities that has been happening in your system. It can correlate the different kinds of events. It can show you different kinds of visualization based upon statistical analysis. And also we have been identifying the threat and vulnerabilities that might occur in future. They are doing prediction also. They have been showing the recent vulnerabilities also. So so that's where we need to think about the machine learning algorithm, application of machine learning algorithms also. So where there are few use cases, like let's say user Joe logged in more than other users in a particular day. So it looks like this. So there are other users, Bill, Sita, Ram, Joe. So whenever Joe logs many times, then that has to be notified, because that is not the normal activity that is done by the other users that is assessing the system. So that might be one of the important insights to look at. Then another thing is like we can do the enrichment. Enrichment is like, so we have these kind of like Joe reads the balance sheet. Then that balance sheet, we can say that this is associated with the human resource group. So that is the enrichment we can do. And in some cases, what we can do is if Joe reads the file, then we can say that the action is enabled. So he is assessing the file. So we can say that that action is enabled. And also in some cases, if the blacklisted IP is assessing the source, then we can say that this is a threat category. So we can mark it as a threat. So all these activities which we are mentioning has been done by the users. So, and as I mentioned before, so one of the important thing we need to talk about is the behavior of the users. So we need to identify the behavior of users. So that's where the term user and individual behavior analysis comes. And it is basically it basically is associated with the activities that is being done by users daily. And what we do is we analyze the data that is being generated by each and every users that is accessing the system. That might be in a distributed environment, that might be in the cloud. So all these activities are being collected and analyzed, and to detect the insider threats. So whenever we talk about insider threats, we need to talk about the on-premises system, right? And we need to talk about the users which are accessing the system in the cloud. So in both cases, we need to talk about the behavior of the user. So what we need to do is we need to monitor the user's activity per minute, or maybe we need to monitor the activity of user for 60 days, and all these activities we need to identify. So sometimes we need to monitor the activity of user in real time. Sometimes we need to monitor the activity in past 1 month or 2 months. So all these things we need to monitor. That's where this UEBA system comes. So that's why what we do is, so in real world, so as I mentioned before, so the user that is copying the file from the system in a abrupt manner, that might be happen in very few cases. So what we say is there is highly imbalanced data set in real world, and so we need to think about that. And also we need to talk about the like pushing the speed, that is taking into identifying those kind of threats. And also we need to identify the new classes, like as I mentioned before, those things which might not be seen before might be seen now. So all these things, activities can be has to be identified. So all these cases we need to identify. So that's why what we did was we actually did first with some experiments with the standard data set, and we extract the features from those events, and we apply deep learning algorithms to model the user's activity and behavior. And we identify the users that has done the activity which is different than the activities which is done by the other users. So the approach which we used, and not normally this approach can be used by all of us to identify those behaviors which has been done by users. Like, so what are the activities that can be done by the user? Let's say the user can access the device log. User can access the web page. user can access the email, user can log into the system, user can access the file. So all these activities has to be logged, and based upon all these activities of the user, we actually extract the features, and sometimes we enrich those features. So whenever we see as a vector, like for each user, what we have is, for user one, we have feature one, that is might be the access to the device. We might have feature two, that might be related as HTTP actions, and there might be other features. So for each users, we have different kinds of activities. And what we can do is, as mentioned before, so what we can do is, we can actually work on each session that users has performed, or we can see what are the activities that is being done by user throughout the day, right? So there might be different approaches. So it means that, so once the user logins to the system, we record the event, that is activity that is performed by the user, or and once the user log out, then we again, and whenever user log in again, then we again track the activity. That can be one thing. So there might be session-based approach. Another approach might be the day-based approach. So entire activity that is done by the user throughout the day that we can monitor. So that's what we did. So we actually monitor the activity that is done by user throughout the day. And so as mentioned before, so we need to identify the users' behavior based upon the other users also. We need to identify the activities that is being done by the activity which is done historically also. So those two things. So that's what we are doing. So we are feeding to the system with all the activities that is performed by the user daily, and all the users, and also the historical data of each user. So and based upon that, we train the model, and then we know that these are the activities which is done by the user are vulnerable, and these are the activity which is done by the user are not vulnerable. So that might be case for the standard data set, because in the standard data set we have all the markings, like these are the anomalous activities, these are the abnormal activities performed by the user, these are the activities that is not anomalous performed by the user. So we can mark that, right? So normal activity and anomalous activity, we can mark that. But in the case of real world scenario, we might not know, there is no marking. So we don't know what are the anomalous behavior and what are the normal behavior. So we need to find some approach which identifies whether it's malicious or not. So one of the approach can be like, we can plot the statistical distribution of all the users, and based upon that we classify the normal and abnormal user. One of the approach can be that. But what we did was, we use deep learning based approach to identify this classification approach. We use a deep learning approach to identify those cases. And for validating the approaches which we are using, before implementing in the real world, we use standard data set that is being released by Carnegie Mellon University. That is the data sets CRD 4.2 data source. It has 3 use cases. One is fraud use cases that is related with the users logged in. After 1 hour, he connects to the external device and he busy stack inside. So that is one use case. So second use case is the users visiting the job hunting site using USB drives at a higher rate, right? So that is the case which I told you before. So users is visiting, user wants to move on, and he is downloading. He might be copying the files to his copying the data to his USB drives. And another is like the IT admin has logged on to other PC after an hour, and he has connected to USB drive and copied the file. So one of the important thing we need to monitor is the IT administrator, right? So IT admin of the system also. So those are the 3 use cases that have been identified in this data set. And for these 2 use cases, they have a lot of events, like they have different kinds of log sources. They have the HTTP, device, email, logged in file, and psychrometric.csv. All those events are there. And from those events, what we did was this is one of the plot of login and log off. So what we see was the normal time was normal time for login was 6:38 to 7 a.m. and the mean duration was 9:38, and the normal time for logon was 7:21 to 7 p.m. and the average time was 5:21 for this data set. So this is the distribution of login and log off. So these were the activities that is only related with login and log off. So there are other activities also. What we did was, so for this data set, there were the data was for 501 days, and there were 1,000 users. So what we did was, as I mentioned before, so we actually aggregated the data for each user per day, and we actually supplied those data to the machine learning system. So since we don't know whether the data is malicious or not beforehand, so we use unsupervised approach, right? So one of the approach we used was autoencoder based approach. So in this what we did, what is general philosophy is there is encoder and decoder. Encoder compresses actually the original input, and then actually decoder decompresses those restore the original data. So that is the philosophy that has been used by the encoder and decoder. And so this philosophy is used. And another philosophy we used was using GRU. So in this architecture, what we do is we actually supply the input, and based upon that, we identify the hidden states, and those hidden states might be related with the abnormal behavior that has been done by the users. So so we actually do it this way, and then we actually generate the output. So what we did was we experimented with the GRU. We experimented with the LSTM for all these use cases, and the challenge was like there was unbalanced data set. So that is one of the important thing, because we have 85 use cases of this use one use case, 861 for use case 2, and 40 for use case 3. So even though we have these number of logs in the data set, right, 25 million events or logs in this data set, but there were very few cases related with the these activities. So we try to identify whether those were normal or malicious. So we did that, and the true positive rate was 80%, 77%, and 80% for these cases. And basically what we did was we compared the performance of this LSTM and GRU, and the GRU performed better in terms of true positive rate. So but the time for, and also the time for training was smaller. So that is one of the conclusion. But the problem with these GRU and LSTM is basically it's taking a lot of time to train the system. So what we did was, so since we have very few cases of normal malicious data sets, so these abnormal data sets. So what we did was we actually train the system. We actually classify the normal and malicious data sets, and we actually supply that to ResNet model, and then we actually train the Siamese network. That is basically very it takes the very few data to train the model. So the challenge with LSTM and GRU is it doesn't works with the new. If you add new data set, it's very challenging, and it's taking a lot of time to identify the vulnerabilities in the real time. So we come up with the Siamese network and actually the performance with the Siamese network is like we need to train very few data sets, like one normal and one abnormal data set, or we might be 3 normal and 3 abnormal data set. We train in like the very few data set. We train or we generalize the anomalous behavior and normal behavior. So so we did like that, and the performance was quite impressive for the same data set which we have used in the case of those LSTM and GRU. So for 3 use cases, what we found was the accuracy was appreciable. The accuracy was appreciable for all of the 3 use cases, and compared to those LSTM and GRU, and we actually validated the result using statistical method. Okay, so so now I would like to conclude my presentation. So basically, whenever we talk about these deep learning methods, so first we actually focus on the insider threats, and we used insider threats because those people who are working on the organization, they are doing the lot of security breaches. So we focus on the user behavior analytics, and rule-based approach is not always enough to identify those vulnerabilities. So we explored the deep learning based approach, and it was identified that GRU based approach is better, and also for real-time analytics and to identify the vulnerabilities in a real scenario where we have very few samples related with threat. So one of the approach can be done by using few short learning, that is the Siamese network, and the performance using the Siamese network was appreciable, and compared to the model using GRU and LSTM. Okay, that's it. Thank you very much once again for inviting me. So any questions?
So this is a virtual session, so questions will be taken later by the students. So thank you, Dr. Basant Joshi, for your enlightening words. It was a pleasure to listen to you give insights about insider threat detection using machine learning. We feel privileged to have your supervision backing us. Your talk was particularly insightful at the time when students are considering new ideas to broaden their knowledge for expanding growth in the field of machine learning. I believe your words have set new levels of expectations that our students aspire for. On behalf of MIT University, Uttar Pradesh, I would like to extend my warm gratitude. Knowing how busy you are, we really appreciate the time you took to impart us with your valuable knowledge. We are highly grateful to have with us. Thank you so much, sir.
Thank you very much. Namaste.
So good evening to all the dignitaries, professors, participants present today. On behalf of MIT University, Uttar Pradesh, Department of Computer Science and Engineering, MIT School of Engineering and Technology, I, Dr. Shilpi Sharma, feel privileged to extend my warm welcome to one and only the keynote address for Confluence 2022 12th International Conference on Cloud Computing, Data Science and Engineering. Even though we would like to invite Professor Dr. Joshua DeCastra to our campus and have the keynote session in person, but current world scenario impede us from doing so. Luckily, we are grateful to have the opportunity to keep the keynote session in a virtual mode so that our students can reap the seeds from the knowledge gathered in this session. Dr. Joshua DeCastra is a technical fellow in the Cyber Security Collaboration Center at National Security Agency. He received PhD in computer science from the University of Maryland. Dr. DeCastra has held a variety of technical and leadership positions at NSA. Most recently, He served as a senior researcher within NSA Research Directorate, studying computer networks operations. His work has also included penetration testing, digital forensics, and malware analysis. Sir remains an active collaborator with academic, industry, and government researchers around the country. He has received numerous noteworthy awards, including the Presidential Early Career Award for Scientists and Engineers, Galileo Award from the Director of National Intelligence, and NSA Research Team of the Year. He was recently named to be NSF Cyber Corps Hall of Fame. Dicastra is a lifetime and distinguished member of ACM. His doctoral research explored new technical and legal mechanisms to support digital forensics for cloud computing environments. Sir, we invite you on the platform to share a few words with us on partnering from prevention in modern secure cybersecurity. We welcome you, sir. Please.
Thank you. It's a pleasure to be here. I appreciate the opportunity to speak with you all, and I'm sorry that I couldn't be there on campus. Let me go ahead and share a couple of slides, which are just meant to help keep me on track. And so, yeah, I actually had visited Amity in 2019. I had the opportunity to come as part of the ACM Distinguished Speaker Series and had the opportunity to talk about cybersecurity science and meet and interact with many of the students and faculty. It was a tremendous visit, my first visit to India. I'm speaking today in a different role. As a US government employee, I work in the National Security Agency's Cybersecurity Collaboration Center. And this is a place where we partner with our industry partners, particularly in the defense sector, companies who have contracts with the US government, because they have a lot of information we want to make sure is protected. And NSA does a lot of work with those partners in addition to our primary goal, which is to protect the defense networks, national security systems, those computers and networks that are used for the US government. And so that's a real challenge every day, but it's a delight to talk about some of the things that we have learned that I think will be beneficial to you. And in particular today, I want to talk about how important it is to partner with other people, because that is the way to prevent the cyber attacks that can be so impactful. As you know, there is no one immune from cyber attacks. Every person, every company, every business, every government is vulnerable, and we must continually work every day to try and prevent that kind of loss. If you look at the statistics, IBM's cost of a data breach report comes out every year. They try and put a value on how much does the average data breach cost. And a year ago, it was more than $8 million US, which is a large amount of money. It is more money than many companies can afford. And so many companies have to close after that kind of a catastrophe. But it's not only about the expense of cleaning up those attacks, but maybe sensitive information was lost. Maybe trust was eroded. All of those things have value. It's not just about successful companies, but we as individuals want to make sure that our information is secure, private, and there's lots of technical approaches. You've probably heard lots of talks today about technical approaches. I want to give you a couple of examples of things that you can do on the human level in addition to the technology level. That's something that I've come to understand, having worked for 17 years as a PhD in computer science. Humans matter a lot in this. And partnership is one part of that human aspect of cybersecurity that we should spend a lot of our days thinking about. So let me start with a case study. This was an attack last year in 2021. It's a public example. It is not something that NSA did work on, but I thought it was a recent example. And there are lots of third-party risk situations. The Target attack in 2013 was one example. Kaseya was another vendor who provides software that lots of other companies use. It does management of networks and computers. And in the middle of last year, about July 2021, they had a supply chain ransomware attack. And that attack affected lots of the customers who use this software. So even businesses who were very secure to begin with were then all of a sudden exposed to a risk because this third-party piece of software disrupted their business. One example is a grocery store, a grocery chain in Sweden, who had to close almost 800 locations because this ransomware disrupted the third-party system that they were using. It's also an example not only of that third-party risk, but third-party collaboration. So as this attack was unfolding and the security community was noticing what was going on, one place they collaborated was on Reddit. And the security company Huntress Labs started a thread that has thousands of comments you can go read, where in near real time, they were sharing information about what did everybody see? What were those indicators of compromise? What were the signatures that could be used to detect or to prevent this kind of attack if you were a company that was involved? And so I think it is both sides of this same story, which is third-party collaborations, partnerships can expose us to risk that we need to understand, but collaboration and partnerships also allow us to do even better cybersecurity than any one company, any one person can do all on their own. A Gartner report a couple of years ago said that the average number of contacts that a business has is around 5,000 third parties. That was a much bigger number than I expected when I read it. And I don't think that's because we have 5,000 pieces of software that we have purchased, but businesses have relationships. And every one of those is an opportunity to build the business, but it's also a potential risk surface. Not every third party that we work with is a problem, but in the same vein that we talk about zero trust principles, we should not presume that every business that we work with is secure and trustworthy. On the contrary, zero trust says we should always assume breach. We should always assume that the person we're talking to, the computer that we're using is insecure. And that leads us to take very different choices in cybersecurity. That Gartner report that said there were average 5,000 third parties also said that the majority of data breaches used a third-party cybersecurity gap. So this isn't a small, insignificant problem. It means we have a lot of opportunity as researchers, as software developers, as students, to do more work that helps the ecosystem of cybersecurity understand third-party risk. And we need to find ways to lower that risk because right now it's a real catastrophic problem. So if that continues to be true, and there's no reason to believe this trend won't continue for a while, what can people do about it? One thing that NSA does is put out the top 10 list of cybersecurity mitigations. This is something that you can get on our website. And I want to just talk about a couple. We don't have time for all 10. But there are some things that you can do as individuals that companies can do at the corporate level that can help minimize that third-party risk. And almost all of these are opportunities for you to collaborate with both internal stakeholders and external partners. Number one is that software updates are incredibly important. The number one thing on our list that you can do to be more secure is to immediately install the updates and patches for software. This is very often the remedy to new vulnerabilities, including the Kaseya attack. The company that makes that software, as soon as they knew about it, started to develop patches. And the trouble is not that the patches are they're not helpful, it's that people don't install them. And this is true for Windows updates and updates on our mobile devices. There's this long tail, if you look at the research, about how long it takes for vulnerable devices to get fixed. And so attacks continue because those attackers know these are public vulnerabilities. And so they just try stuff that could have been prevented. So keeping track of that is critical. I think we saw this again with the Log4j vulnerability very recently, where there was so much software that used that library that the vulnerability was incredibly widespread, and that was part of its problem. Being able to update all of the software that used Log4j for some large companies was a real problem that I think they're probably still working on today. But all the digital devices, even in our own homes, some of them also use Log4j, and we also need to wait for those updates to become available. But as I say, the number one thing you can do is install those updates as soon as possible. Number two is to protect accounts. And this is more nuanced than just have good passwords. That's certainly part of it. Having good cyber hygiene is very important. It's foundational, in fact. But account exploitation and people using legitimate accounts still poses a real problem today, which is unfortunate. I don't see the end of this problem on the horizon quite yet. I think there's many opportunities for us to figure out how to strongly authenticate people and machines to make sure that compromised accounts have a blast radius that we can contain and control how much damage can be caused, to detect misuse, and to mitigate it as soon as possible. Certainly, you can help the situation here by using, for example, a VPN. A VPN helps protect accounts on lots of levels, but as the Kaseya and Pulse Secure, for example, illustrates, during telework and during COVID, some of these protection mechanisms became the target of attackers. So attackers said, lots of people will work from home. They will all use their VPNs because they're good security, safe companies. And the attackers started going after the VPN software. And Pulse Secure was one example of this. But thankfully, it's another example where the community came together to more quickly detect and mitigate that threat. Mandiant FireEye, I think, was one of the first public companies to put out a report. They also did an evaluation that said, this is very serious. They said the CVSS severity score was 10 out of 10. This was the top priority for companies when it came out. The government also played a role in this because we had people and customers who use this kind of software. And in the US, the responsibility for protecting the software falls not only with NSA for defense systems, but Homeland Security for domestic systems and the FBI for criminal activity. But we also worked with those defense companies, like I said, some of whom were using this software. So we would talk to them and say, are you seeing attacks and where are those attacks coming from? And we could help develop signatures and mitigations. We could share the information that other parts of the government were discovering and more quickly get out information that helps protect all of the users of this software. This would never have been possible if we didn't have relationships. And so my office spends a lot of time building relationships and talking to our partners so that before anything bad happens, we already have a good working relationship. And in the unfortunate but inevitable situation where there are compromises and attacks, those will never go away. We can very quickly work together to do the remediation and mitigation. And everybody brings different skills. There is no company on this planet who has all of the skills and all of the knowledge to fix cybersecurity. If they did, they would be making a lot of money, but there is no one company who can do that. And there is no one government that can do it. The US government does not have universal access and insights and all the cybersecurity knowledge on the planet. And so we must work with other people to do that. And I think that's true. We should acknowledge that no matter what our role is. If you go and work for a cybersecurity company, take the opportunity to build relationships that can help you and the partner do better. Number 3 on this slide is to have and practice a trustworthy incident response plan. Being prepared comes a lot with doing the preparation. If we end up in a crisis and then have to decide what to do, we won't make very good decisions and choices to be able to respond to those attacks. And we see this a lot with public data breaches where we read in the news that a company had a problem and then they just shut down their entire network. And to me, that is an illustration that they weren't ready. They didn't have a plan. They hadn't practiced that plan. And so it probably cost them downtime and money that they didn't need to spend. And that's unfortunate because we should be taking the time before the crisis happens to be prepared. I gave a talk at Black Hat in 2021 about a topic called action bias. And action bias is related to this trouble, which says in a critical situation where we don't know what to do, it is human instinct just to react. This is built into our DNA. If it seems like we are going to be attacked by an animal, our instinct is to run, right? The fight or flight biologic response. But the same thing happens in a cyber intrusion. We just want to do something. And if we haven't thought carefully about what is the right thing to do, we will sometimes make less optimal decisions. So you can certainly find that talk on YouTube if you want. It's very much along this line of create your incident response plans now, practice those plans, don't just have a playbook on the shelf. But for example, we teach children if there's a fire in the building, here's what you do. You leave the building and we all meet outside and make sure that everybody is safe. And we practice those plans. We need to do that for cyber attacks as well. The last thing I want to mention here is to continually hunt and remove bad actors from your network. The zero trust principle is that we should assume compromise make this one even more critical than it has ever been. This recommendation has been on our list probably for a decade, but I would say it's more important today than it was in the past. Continuous hunt is a very different approach than, for example, penetration testing or red team, which is a maybe once a year or once a decade, depending on your company, going and looking for hackers, malicious actors in your network. In reality, we have to be doing that all of the time, continuously. And the same is true for reevaluating trust. We need to continually reevaluate, is this still Josiah on the computer? Not just the one time that I log in, but every second, every time that I interact with the computer should be validating, do I still believe this is Josiah? Has somebody taken over his computer? Has something else gone on that we can detect? But the sooner that we find those bad actors, the sooner that we can understand the threat and mitigate the threat. So doing it once a month or once a year is just not sufficient anymore. We must be doing it continually. And you can do this with layers of security. We always talk about defense in depth. And so having antivirus and a safe browser and a firewall, all of those pieces can play a part in this continual security. The other note that I'll say is that if you assume that your network is compromised, it can be challenging not to reveal to the adversary that you are trying to get them out. Because if they see you trying to get them out, they will probably take other actions as well. My recommendation here is to get logging information to a safe, secure environment as quickly as possible. So if your machine logs every time a human authenticates to the machine, if the last talk was talking about this, make sure those logs are removed off the device as quickly as possible. You don't want the attacker to be able to tell that you are analyzing those logs and that you have detected their presence. So doing that as quickly as possible certainly can be helpful. The other area that I wanted to mention briefly, given the topic of the conference, is cloud. In very many business environments and many attacks that we are seeing more and more every day, cloud plays a component because it is so ubiquitous. There are something like 20 billion connected devices. Almost all of them use the internet, and very many of them talk to internet-based cloud systems. So protecting the cloud is more important than it has ever been before. And there's needs for new skills. People need to understand, what do cloud security logs look like? And how can we write analytics to detect compromised cloud-based email, for example? Some of the lessons that we learned in on-prem host-based cybersecurity do apply, but there's lots of new things we need to take on too. Cloud also has a really interesting intersection with communication. And so 5G, for example, is a very cloud-heavy technology. 6G will be even more of this. So NSA and our partners at Homeland Security recently put out a 4-part document on protecting 5G cloud infrastructure. You can find these documents on our website, on the Homeland Security website. And it's very much an interesting view into how to protect the core architecture of 5G. It's not particularly meant for end users, but there's lots of lessons I think you can learn about how does secure software development play a role in protecting 5G as an ecosystem, 5G core in particular. And what does micro-segmentation mean in a 5G system, and how will we need to protect that use in the cloud, which is similar or different from the way that you might use cloud today. 5G is a very complex ecosystem, as you may know, and there are many components that must be protected. There's a lot of research I know in a field called composable security, which is even if one component of the ecosystem is very secure, very safe, do the combinations of multiple components change the security level? Could there be introduced vulnerabilities just because two secure systems are talking to each other? For example, if you believe that your smart device is perfectly secure and you believe your smart watch is perfectly secure, when the two things communicate with each other, does that introduce any new vulnerabilities? And I think that's a really complicated problem in cloud and 5G ecosystems, but it's one that I think we all should be wrestling with. The cloud vendors today are already trying to do this, but there's many more opportunities. The cloud will grow and evolve, and I encourage you all to think about this. My PhD dissertation work was in digital forensics for cloud computing, and that was already almost 10 years ago. And it has come a significant way, but that is still a really good PhD dissertation topic. And I'd be happy to talk to people if you were interested in that. So my key takeaway for today is try to understand third-party risk. It is no longer sufficient just to think about the security of a single user, a single device. We have to interact because of modern technology with other people, with other software, and understanding the risk profiles of those things is very important. The flip side of that third-party risk is third-party collaboration can be an incredibly useful and powerful tool. So seek to grow your relationships, your professional, personal relationships, so that as cyber attacks inevitably occur, you are prepared, you are adequately ready for when they come to quickly respond, to quickly bounce back. There is no end to our jobs in cybersecurity. That is why I love my job. There's always new things to work on. But we can be more effective in those jobs if we do this. You can get lots of the NSA's public guidance on our website, nsa.gov/cybersecurity. It's where that 5G report is. It's where our top 10 list of mitigations is. You can also find emerging threats on our Twitter feed, NSA Cyber. All of the information that goes out on that Twitter feed is very related to cybersecurity. It isn't a recruiting tool. It is very much meant to help people defend networks. So thank you for having me. I look forward to all of your contributions in this field and eager to engage with you at some point in the future. Thank you, everybody.
Thank you, Dr. Joshia, for enlightening words. On behalf of Amity University, I would like to extend my sincere thanks. It was a great pleasure to listen to you giving insights about partnering for prevention in modern cybersecurity. We feel privileged to have supervision backing on us. Thank you so much, sir. Roshan Lal, sir, may I request you to kindly introduce our next speaker of the session?
Yes, ma'am. Yes, ma'am.
Professor Dr. Om Prakash Agwan, sir.
Yeah.
Thank you.
Yes. Good afternoon to all the dignitaries, professors, and participants present today. On behalf of the Amity University, Uttar Pradesh, Department of Computer Science and Engineering, Amity School of Engineering and Technology, I feel privileged to extend my warm welcome to one and all for keynote address for Confluence 2022 12th International Conference on Cloud Computing and Data Science and Engineering. Today, I am happy to take the opportunity to invite our Honorable Speaker, Professor Dr. O.P. Sagwan. Sir is a professor in Guru Jambeswar University, Haryana, India. Sir has contributed diligently in the field of the software engineering, soft computing techniques, machine learning, and artificial intelligence domain. Sir has contributed a lot in these fields with his technical acumen and distinguished work. Sir, we invite you on the platform to share a few words with us. Sir, you are most welcome, sir.
Audible?
O.P. Sagwan, sir.
Am I audible?
Yes, sir. Yes, sir.
I'm audible.
Yes, sir. You are audible, sir. Please share your presentation, sir, and you may start.
Just a moment.
I am audible, sir.
Huh?
I am audible.
You are audible. You are getting my sound?
Yes, sir. Yes, sir. You
Okay.
are audible, sir, now.
Okay. Let me, there is some issue with the sharing of slides. Okay.
Yeah. Please.
A very good evening to all of you. Thanks to Dr. Roshan Lal for introducing me and giving me an opportunity. I am very thankful to the organizers, especially Professor Abhi Bansalji and all, to discuss with the all related with the key issues that you have taken on this conference 2022 that is based on data science engineering, right? So I'm going to discuss few points on this regarding this. Nowadays, you all know about that the big data analytics is one of the key area in this particular field, or you can say that related to data science and engineering. So today I'm going to discuss this, that how we can use data analytics techniques, or how we use data analytics tools to deal with the large scale of data sets. If I'm talking about data analytics, so we all know about that it is basically a collecting of data from different sources to merge it and to deliver it in a useful product that is useful for the business organization. The basic core objective of this big data analytics is a process, you can say, of converting large amount of unstructured raw data that is retrieved from the various sources to a data product useful for the organization. That is basically the core objective of this big data analytics. Then you all know about that there are 5 ways in B model: volume, variety, velocity, veracity, and volume. So basically the task of this big data analytics, you can say, it is a kind of technique that is used for analyzing big data sets to gain some meaningful insights so that it can be used for the various business applications, or you can say in enhancing day-to-day human life. So if you look at this, I think the slides are not visible because the sharing option is not available. So if you look at this in today's scenario, if you look at it, we have the artificial intelligence, we have the data analytics, and we have the big data. So if we're combining these 3 fields, and that needs to be combined, looking at that demand of today's scenario, if this artificial intelligence, data analytics, and the big data, and that combines the collective skills and knowledge required to capture import processes, you can say, that is required, and build algorithmic models on data in order to deliver the tangible business outcomes. So if you look at the talent demand in AI and big data analytics, so I'm just taking here a reference from the NESCOM. According to the NESCOM, if I'm talking about the present talent demand and supply report, you will find that in 2018, the total job opening are 1,40,000, and the university talent that is available is the 78,000 only. And if you look at this talent demand supply gap in 2021, the total job openings are 2,30,000, and the total demand supply from the, or you can say the university talent is 90,000 only. So there's a huge gap on this. So how we can build up these gaps? Now, if you look at this, the various streams from where we are getting this skilled students, in the field of big data analytics on the machine learning. If you look at this, 72% from the graduate, 23% from the postgraduates, 3% from the PhD, and 2% from the integrated sources. If you look at this, split in academic streams, I'm talking about the various kind of disciplines like computer science, mathematics and statistics, information technology, electronics engineering, electrical engineering, mechanical, and you are in other branches of engineering also, like your chemical engineering, civil engineering, metallurgy engineering, and mining engineering. So you'll find that in case of students graduating in computer science, mathematics, statistics, and information technology, have more relevant skills compared to the students graduating from the other streams. So this is what the present scenario in the big data analytics is. I'm still audible, Doctor? Hello?
Yes, sir. Yes, sir.
Okay, okay. Thank you. Sorry, I'm not able to share the PPTs. If I can, yes.
You may try, sir.
Okay, wait, let me.
Yeah. It's a visible, sir. Visible.
Visible. Okay, thank you.
Yeah.
I can put it in.
Yes, sir.
Full screen. I'm extremely sorry for this.
Now it's okay, sir.
Okay. So if you look at this, is the let me share with this is an important slide that I want which I have discussed. That is, look at the total requirement. You can say this is what I was discussing about, that total talent demand and supply gap. So you can see in 2021, so total job opening are 230,000, and the talent that is required, or that we as a university was producing talent, that is 90,000. So there is a big shortage of this. And this is what I'm telling about the different kind of streams. I'm telling about the different kind of levels of education from where we are getting these students. So if you look at this big data analytics cycle, if I compare with the traditional, this is a traditional analytics business cycle. We start from the understanding the business, then data understanding, then data preparation, then modeling, evaluation, and deployment. Initially, we have these two techniques are available. If I'm talking about the traditional data management, this is one is the CRISP DM methodology, and the other is the CIMA methodology. If I'm talking about the CIMA methodology, that talks about the sample, explore, modify, model, and assess. There are some sequence of steps. However, in case of this CRISP DM methodology, it talks about a complete cycle. Like we have a cycle in software development, life cycle is there. We have a cycle in case of OSI model is there, in case of networking, if I'll talk about. So the main difference between this CRISP DM technology and this CIMA, that the CIMA basically focuses on modeling aspects, and whereas this CRISP DM, it talks about the stages of different kind of cycles, starting from the understanding the problem, and then pre-processing the data, and then finally using the machine learning techniques also. If you look at this big data analytics cell, you can see at the life cycle. So it starts from business problem definition, then we look at the research, then we'll do the human resource assessment, then we have the data acquisition, then data mining is also there. Data storage is there. There's a need to perform the exploratory data analysis, then data preparation for modeling and assessment, then modeling, and then implementation. So we have to go through the number of steps. So you can find this from identifying formulation problem, then data preparation, then data exploration, then transform select, then build model, then we have to validate that model, then deploy that model, and that evaluate and monitor and the results. This is basically the complete cycle of this big data analytics. So this is about the, if I'm talking about this human resource assessment, this is one of the important part of this life cycle. In this, you will analyze if the current staff is able to complete the project successfully. If not, it might be possible the traditional development team that we have that is not able to deliver an optimal solution to all the stages, or you can say to the current problems. So it should be considered before starting the project that if there is a need to outsource a part of the project or hire more people, like we do, or even the industries also do, they will take the expertise person from this. So this is how the various steps are used in this. The kind of methodologies. If you look at this, the big data analytics code delivery, if I'm talking about this code deliverables, so that is a machine learning implementation is there. So we have a number of algorithms for the classification algorithm, for the regression model, or the segmentation model, a recommended system. That is also the one of the deliverable of this big data analytics. And we all know about the Netflix is a fantastic example of this data product, and that is based on the rating of users. It will, you can say, it recommend the movies, right? Then we have the dashboard is there. That is basically a visualization of aggregated data is there. We have the ad hoc analysis are there. So these are the few, you can say, deliverables of this, right? Then we have the key stakeholders related with this. Check who and where the sponsors are. One that interests you, having personal contacts in the key management positions helps you, so that any contact can be triggered if the project is promising. So who will benefit from your project, and how would be, you can say, your client, once the project is on track, then develop a sample, clear-cut proposal, and share it with the key players in your organization. And this particular, if I'm talking about this particular slide, that also belongs to the National Education Policy or Government of India. That is, whatever you are doing, that how we can make it more flexible and how we can make it more practical with this. Then we have the look at this problem definition and big data analytics. So most of the data problems are in different kind of categories. We have a supervised classification, unsupervised regression, unsupervised learning is there, supervised regression is there, or learning to react, that is level 2. Training the data is also there. Then there are certain tools of big data analytics. I'm not going to take all this, but I just give you I will share the PPTs if required. Then we have the R programming environment is there. So that is basically open source programming language that is focused on statistical analysis, right? Then we have this Python for data analysis there. You are using Python, and we are using R also in our research works. Also in the most of the development, this Python language is used. It is also a general purpose programming language, and there are significant number of libraries that are devoted to data analysis, such as Pandas, yes, Skippy, Vanami is there, right? So better choice than R if working with the large data sets. So depending upon the nature of the data sets and kinds of data sets, we can do this. We have Julia, that is also high performance dynamic programming languages that is used for technical computing. Right, it is a similar kind that is with the R and Python. If you are working with the Python and R, so you can simply work with the Julia. So it's a great tool for research in terms of implementing a model in production. Probably Python has a better alternative. Then we have the statistical analysis softwares are also there. So the main purpose, if you look at this, for the statistical analysis software, is to retrieve, report, and analyze the statistical data. So we can recommend the SES in the case if we have a small data set and the users are not much expert data scientists. So in case of, you can say, research, or we can use this SES tools also. Then we have the SPSS tools. So you all are familiar with this particular tools that is widely used in management also, and in engineering also. That was, you can say, the IBM. And basically used for the various kind of researches for complex statistical data analysis. So depending upon the nature of problem, we can have the different kind of tools. And it is a decent alternative for the users that are not able to program. So from the who are not familiar with the programming, they can use this SPSS tool also, right? So for a small data set, for unexperienced team, so SPSS is an option as good as SES is. Then we have the MATLAB and is also there. So this is an open source software is there. So what we can do with the R and Python, that R can be available in MATLAB and Octava, but MATLAB is a licensed product, right? So if you do, if we need much more advanced features, in that case we can go for the MATLAB also. Otherwise, we can work with the open source softwares also. Then we have a Apache Hadoop is also there. So that is again an open source framework that is hosting a huge amount of data set with clusters of commodity. So we have two kind of components is there. One is the SDFS, another is the map reduce, right? So that is again SDFS is work on write once, read any number of times, right? Then we have a Apache Storm is also there. That is and is a real-time processing framework that is for data streaming processes, and we support any kind of programming languages, right? So if you look at these Apache Storm, so the following benefits we can, there's a great horizontal scalability, they are built-in fault tolerance is also there, auto restart on the crashes. So that kind of facility is also there with that. Then MongoDB is also used for the distributed database, right? So it's a high availability, horizontal scaling, and it is easy to use. So best it is working for the data set that vary or change in frequency with a semi-structured or unstructured data set. So whenever we have a heterogeneous kind of nature of data is there, when we have distributed database is one of the best option we can do this. Then we have the Cassandra is also there. So this is a highly scalable, high performing distributed database, and that is basically designed to handle large amount of structured data across many commodity servers, right? So it is a highly scalable, fault tolerant, and it is a consistent. So there are a number of companies I must share with you that is being used by the biggest companies such as Facebook, Twitter, Cisco, Rackspace, eBay, Twitter, Netflix, and more that are using this Cassandra big data analytics tool for their analysis and business purposes. So we have Apache Spark is also there. So Apache Spark that is basically address some of the shortcomings of the Hadoop, right? And it does this incredibly well. It can process both batch data also and real-time data also, and operates 100 times faster than the MapReduce. So basically, the Spark provides in-memory data processing capabilities thereby making it way faster than the disk processing average by the MapReduce. Then we have one of the open source that is available, that is Google Colab. So there is a Google Collaboratory, or you can say Colab. That is a product of Google Research. You can install it, you can use it freely. There's no problem at all. So it is a Jupyter notebook environment that runs in the browser using Google Cloud. So Colabs allow anybody to write and execute arbitrary Python code through the web browser, especially well suited to the machine learning, data analysis, and the education. If a student is doing research in this particular field, so he or she can use this. This is a good option. Google Colab is a good option. And if you to look at the technical point of view, so Colab is hosted Jupyter Notebook services that requires no setup to use, by providing free access to the computing resources, including the GPUs also is there, right? So so Google Colab notebooks are stored in Google Drive, or you can load from GitHub also, right? So you can just the Google notebooks can be shared. Just you would like to share your Google Docs or Sheets, right? So simply go to the share button and you can share. If you look at some applications of this big data analytics, where we can use this big data analytics, so we can use in the commerce also, we can use in the marketing, we can use in education, we can use in healthcare also. Besides this, we can use this in media and entertainment, in the sector, in the banking sector also, in the telecommunications sector also, and recently the government is also using big data analytics just in law enforcement or among other things also. And just to take the feedback from the customers for any policy related feedbacks, then the government can also use this, or presently using this big data analytics tools for this. Then if you look at this conference part, so machine learning for big data analytics, I'm talking about this. So you can look at this. This is the classification of machine learning techniques. We can have supervised, unsupervised, and reinforcement learning. So depending upon the nature of the data set and all, we can go for the classification, we can go for the regression also. So these are the various kind of machine learning techniques that we can use, that we can apply for big data analytics. So finally, we have the benefits of this big data analytics tool. So cost reduction, that is one of the advantage, one of the benefit of this big data technology. So Hadoop is, you can say, cost efficient for storing large amount of data. So it is compatible. It is also compatible with the other platforms, and now the users are very friendly with the Java language. So Hadoop is basically based on the Java technology. The second advantage, or you can say benefit of this big data analytics tool, is a fast decision making, just to ability to analyze a new source of data, and which makes it easy for the organization to analyze information quickly and aiding faster decision making there. Then the risk management that we can also do with the help of this big data analytics. I'm sharing here example. Banco de Oro, a Philippines banking company, uses this big data analytics to identify the fraudulence and activities and disturbances. And it is proved and found that the organization leverages it to narrow down a list of suspects and root cause for the problem, and then they look at the solution of that. Besides this, we can have this product development and innovation also, right? So Rolls-Royce, one of the, we all know, one of the largest manufacturer in the jet engine, that is for airlines and armed forces. So they are using these big data analysis techniques to analyze how efficient the engine designs are, and if there is any need of improvement. So with the help of these techniques, they can do the better improvement in their existing designs and this. Improved customer services also, again, I have taken here one example of Delta Airlines that uses a big data analysis techniques to improve the customers. Whatever we used to discuss on social media platform or others. So they monitor the tweets to find out the customer's experience regarding the journey, delay or soon, right? And they just focus on the negative, you can say the comments, negative tweets, and does what necessary to remedy the situation. And by publicly addressing these issues and offering solutions, it really helped that Delta Airlines build a good customer relationships. So this is all about what I want to share with you all on this important day of this 12th International Conference on Data Science and Engineering. So it's a proud privilege for me to discuss you with all, and I'm pleased to inform all that mostly I've attended all the conferences of this. So that's all from my side. If you can ask any questions, you can ask from me, or you can write to me also. So you can take my this is my email ID, opsangwan@ggusc.org, and you can write to me if anyone is doing research in this particular area, right? So that's all from my side, and thank you very much for giving me an opportunity to be a part of this. And I must congratulate all the organizers for organizing such a interesting and time demand conferences and seminars.
Thank you for your enlightening words, sir. It was a pleasure to listen to you. We feel privileged to have your supervision backing us. Your talk was particularly insightful at a time when students are considering new ideas to broaden their knowledge. I believe your words have set new levels of expectation that our students aspire for. On behalf of MIT University Uttar Pradesh, I would like to extend my warm gratitude. We are highly grateful to have with you, sir. Thank you so much, sir.
Thank you, sir. Thank you. Thank you very much for giving me this opportunity. Thanks to all. Namaskar.
Thank you, sir. Thank you very much, sir.